Hello. Let's start. Let's make sure our camera should be. Very nice. Let's start with actually small software testing because I was doing some changes off stream and I didn't have enough time to test them. So I would like to test this example on stream. This is an example of us measuring our inductance and time constant of electrical part of the motor. So let's just test it from scratch on 12 volts and see if it works. Because I removed some code that was unnecessary. This is in our active experiments. So let's switch to our active experiments. Let's make sure that we are running the example we need. I don't think it is actually. The example we need is 12. So let's switch to 12 and run it. Active experiments. Let me make the font bigger. And let's see if it measures correctly. Run expressions, values. Values seem to be reasonable enough. So not exactly. I believe we were getting different values before. That's awkward. That is slightly awkward. Because yes, they are stored here, so we expect to see a test to see roughly 252 milliseconds and also 15.5 millihenry, but we see quite a bit less. Ooh, that is curious. Maybe we expect some voltage that we do not provide properly. No, we don't. We don't care what the voltage is. Okay, very interesting. Let's try other tests, or rather the same test with other phases. Let's run. Put moved and what values are. They are way closer to what we measured before. They are way closer, but still not exactly there. I'm not sure if it's because the motor is cold-ish or if my code changed something. My code changed something. That I believe I was just removing that code, so it's a bit awkward. But we are quite used to being in awkward situations on this stream. Let's see. Yeah, we definitely measure a bit less than before. For some reason, maybe actually that motor is warm. No, it is actually very cold. Okay. I'd say the main thing is that the example works. As intended, we just measure slightly different values, which is not critical. I'd say let's test our CA phase again. Or rather CA phases, because there are two of them. And let's see if result is close enough to what it was, and we will continue to our PCB design. Okay, it's close enough. Looks good to me. Let's flash our example with motor spinning back and forth, so that we have something dynamic on the screen at all times and at all costs. Okay, this is awkward. Okay, let's see. Are we in a correct build? We are. That's right. Let's make sure the motor calibrates as intended. I think I'm a bit too close with the camera. Let me fix that. Oh, I'm at 12 volts. I should be a bit higher than that. Now I'm 36. And it looks like it works fine. Yes, good enough. Good enough for us. Okay, so we are done with code testing for now. Let's switch to the KiCAD. And let's actually work on the KiCAD libraries and KiCAD redesign of the PCB. So let me open the PCB first. This is the first project ever I've made. Let's open the project. PCB editor is where? Is here. Very nice. And also schematic. Very nice as well. The port is incredibly simple. Let's make sure the model loads. It doesn't load C1. And connector. Actually, let's start by fixing this, because this is annoying. Do we have any errors? We have warnings. Doesn't match the copy. Why though? Let's open our symbol and footprint managers. And let's see what's going on. So here we're supposed to have a footprint associated, which we do. And the footprint is supposed to have a 3D model. So what? No, I don't need a pin. And the footprint, it has 3D model associated with it. Footprints. Okay, so it doesn't seem to be able to find this. Maybe because this route is incorrect. But some files are loading, so it's interesting. Let's see what is happening there. One moment. So we should see this. Footprints, 3D models. Oh, why do I have so little here? Oh, this can be very awkward. Hold on a second. This can be very awkward indeed. Let me open KiCAD libraries. Let me fetch them. Do I have any changes? I don't. Okay, but I do have connectors in here. Okay. So let's see what the issue is with them. Maybe I renamed them. What is the expected 3D model? Yes, it definitely doesn't expect the right name. But is it correct in the library file? So let's open the library file and see. Let's see what we will update first. So footprint editor. And let's see. Connectors. This is this one. So let's see. 3D model is correct here. So we need to update it in the design. And how do I do this? Update. Close. Did it fix it? No. Is there a way I can update the component itself from the library? Update footprint. Update. Close. Oh, it was changed a little bit, I see. Let's do it like this. And let's regenerate our polygons. And let's see if the model updated. It did update. Okay. I think I was changing libraries way after this project was already finalized and produced. So what else? What other errors do we have? The footprint doesn't. Okay. Let's. Can I do the updates for everything? Library browser. Nope. Do I need to do it manually? Or easy refresh? No, I don't need nets. I rather need objects. But I don't have a list. Okay. So I guess I need to Google. KiCAD update footprints from library. Oh, this is alone. Very old thread. Change the footprint, just check. Oh, actually, here with no symbols, override. Sure. Good footprints. No. Override logs. Update footprint fields from symbols. Okay. All schematic symbols based on the reference designator. Group is based on symbol group. So now it seems I cannot do it automatically here. Right? They are not updated yet. So how do I update it then? Let me keep googling. How to update KiCAD footprints. Rather, how to update all KiCAD footprints in the project from libraries. Okay, let's see. Open PCB editor, tools, update footprints from libraries. Okay, that makes sense. There is a separate option for this. Sure. Update all footprints on board. Match reference designator. Match value. Use library. Okay. Remove text with no library footprint. Update reset text layer and visibility. Update reset text size and styles. Update reset text positions. Update reset text content. Yes, update reset the models. Okay, that makes sense. Update. Okay, so I guess I updated quite a few more than I expected. Right? That's awkward. But let's see now if we have any errors. Oh, we don't have warnings, but we now have errors. Was footprint has malformed courtyard, not closed shape. Ew. But this is a component issue, right? This is a library issue. And what was the second issue? Okay, this is the same issue. Oh, I see, and there is no line. What happened? What happened? Where do we store this footprint? There is ICs deleted. Okay. Let's find it. Global ICs. Deleted. Let's start it. And how do I start it? Do I not do it here? Do I do it in here? the library, I see. Makes sense, makes sense. So, and we are working here with what exactly? With PCC OP16. Okay. Okay. So where are we? Here. This one. Yep. The line is definitely broken. The line is broken. How do we solve it? Will this be a solution? Oh, okay. What is this grid man? Now. And this is off grid. What grid did I use to do though? To do them, I used 0.5 grid. Hello? Did I actually? Oh, crap. Seems like I did. Did I actually? Yep, everything is 0.5 grid. Okay. Did I? I'm not sure if I'm a big fan of this. I'd rather put it on 0.1 grid. It's not a big change, but it's more convenient. Way more convenient to work with. Why? Like, it's supposed to be on... Okay, see. It's supposed to be on the grid, but it isn't. Now it is, though. Only have a single grid line here, so we have to do a single grid line here, of course. Very nice. Is it also on the 5 grid? No, it is not. Smaller. And this is here, so it's much nicer. What else do I have here? Because these are... I don't remember of what I was doing here much. So let's just figure it out. So I use 2 custom size, custom layer for value. Because I actually don't like when the value is on the output files. It becomes very messy and it requires you to like effectively, purposely position your values as well as your seal screen, which is annoying and like lots of work. So that's why I use a separate layer. So in case I actually need it, I can export it additionally in our Gerber files. So what else? Datasheet value that is not attached and description value that is not attached. Curiously. Okay. I also don't remember what are the latest components, but I have it in GitHub, so I can look up what were the latest things I was working on to see, actually, to compare if anything is different. Okay. Lots of words here. Sure. Layers. I don't remember this being here. Use custom stack. Interesting why it is a part of a footprint, but maybe some footprints that have through holes may require this. We don't have any. Clearance. Leave values blank to use net class values. Sure. Okay. Path connections. Use zone settings. Sure. Clear model is loading. And is it custom made? I believe it is. And embedded files do not exist here. Okay. So let me open what you are trying to remove the layers that are used by the print. Okay, let's do cancel because I didn't change anything actually. Not break anything. So let me see what was the last effective print I updated, or rather edit. And it was actually connectors were very close to be lost. And also transistor and the driver, motor driver. So let's actually see the motor driver then. It will be, what will it be actually? So 23.6. Oh, it's not a motor driver, it's a transistor driver. I see. Okay. So connectors 4 is the last. Connectors 4 the last was working with. Let's see if they have any difference. They have this line. Do they have any other colors? No. These sizes, okay. Also description is empty, okay. Sure. Nothing custom here, here, here. Here the model. Custom made. No embed files because they were not a thing in KiCAD 8 when I was working with this. So then I think I don't have anything to add for now. Here, let's go back to our IC and let's make sure that this looks proper. This looks correct. Reference, sure. Okay, and this is a screen. Oh, this is also a custom layer. Yes, custom layer 8. To have this for manufacturing files or manual assembly files rather. Also a useful usage of custom layers. Also, why do I have only 6 available? I think it was more before, no? Gulp. Okay, so let's save it. Let's run our update again. Let's run our error check. Very nice, it fixed it. Let's run our polygon fill. Looks very nice. Let's see our 3D model. Oh, so the connector is expected to be on the other side. When actually currently is soldered on the side with the IC. Okay, now comes the hard part. Actually not yet. Not really, not yet. Let's first do our text variables. And let's see, let's say design iteration. And the design iteration file or variable will be 3, I guess. It's what we are working on, but I'm not sure. This 2, and what does schematic say? Schematic say is 2 changed. Okay, perfect. So we are working on version 3 then, correct? I think it's actually different in controller design. Let me quickly check it. So I currently have a version 3 on my table, and version 4 is what I have in the design. And let me actually see what was the last version we built for this PCB. One moment. Okay, this project electronics, this PCB output files, we only built version 3. So I think the idea here then is that I has to use number 3, not number 2, because I'm working on 3 and unfinished, which makes sense. So thinking about it now, I have this like star here, but I will also want to remove the star when I generate files. Or should I? I don't think it's like that much important. I don't think that's much important. Okay, this is rather a guidelines, style guide, design question, and I don't think I will. Not that I will, I don't think I should rather do it on stream, because I'm not sure that people will be interested in watching me designing a style guide on stream. At least not yet. So let's just add our iteration here. And let's keep the star always on. Or rather... Or rather... Yes, I will note it for myself to think about, because this needs to be decided. So think about how to handle a star sign in the iteration versioning. Okay. Too many ink. So, okay. Let's continue what we were doing, which is adding text variable. Text variable, design iteration 3. Perfect. Now let's update our page settings to use this variable here. And let's also update here our silk screen layer to use this as well. Was. Okay, like that. Now it will be updated automatically every time it will change. Very nice, very nice. Is there a hotkey for this? It doesn't seem to be. Okay. Now, what we need to do now is actually to add our pull-ups and inline resistors that we thought may be needed for the SPI to work correctly, because we had issues during our testing with lots of noise, especially from PWM, just because the SPI wasn't pulled up. So let's add the pull-up resistors for master in, slave out. This is required, but we will also do the same for MOSI as well. And in actual design, if it will be not needed, it will be just not used. We can just skip soldering this, or solder it first, test it, and then desolder it. Like when we have a proper applications for components, it's much easier than when we don't, because a few streams ago when I was soldering the components onto the connector, like in a very artificial way, it took a lot of time and it was painful, and chat memed on me for this. So let's just prepare all the positions we may need. So I'd say this should be 500, but I don't think that 500 is a standard nominal. So let's see. Standard resistor values. Let's say E24. And I think Wikipedia has the correct tables. Very nice. Yep, E24s and E96. So what we have around 500, we have 499. Okay. Or we have 5.1. 5.1 is E24, which is more wider available. So let's use 510 then. This will be much better. So no designator when we work with singular units. And this will be a pull-up. This will also be a pull-up. And in line resistors, let's say what will be the value? 10 ohms for now. Maybe it will be less, maybe it will be more. They might as well be, actually, let's put it as 0 ohms. And then if I will see that I need them. Okay, this is an awkward rotation. If I need them, I will just solder the different values. What is this grid snap? Holy cow, what is the grid? Okay, this grid seems correct. Why do I have such a precise control then? Do I have a separate settings for text alignment? Let's see the preferences. Formatting. Symbols, connection text. Default text size, okay. Okay. This is not it. Okay. This is awkward. Why do I have such an awkward net? Do I need to go to the main preferences? So where can it be? A schematic, display options, grids, editor options. Okay. Nope. Nope. Oh, actually very interesting. What is that? Toolbar left. Okay, it doesn't seem to be clickable actually. What the hell? Oh, maybe I need to do this. Okay, okay. Oh, I can do it like this. Oh. Hold on a second. Can I create a completely custom left menu with those? Oh. That is very interesting actually. That's very interesting. I don't think I need it now, but the fact that you can do it, and can you export it? Open preferences directory. Okay. That looks interesting. It's left, right, and top. Oh. Okay. Okay, this is interesting. But do I have a separate grid for... Oh, I do. I see. So grids for schematic 10 mils. 10 mils. But why do I do it? Do I have it? I don't like it. Let's switch it to 50. Now it's much better. Okay, now I like it way more. Wait, it is not aligned? What grid did I use in the library then? Oh my god. Let's open our symbols library. Symbols. Let's open our resistors. Should be in passive. Or not. Mechanics, graphics. New. Should be in passive, no? The hell? What the hell? Resistor. Device. But I don't want this. Do I use not a custom made component? Oh, it's generic passives. I see. Okay. That makes sense. So where was I? Was here. All the start things. And let's see. I just want to add all my libraries to the top. Pin. 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 Pin, of course. And now everything is pinned. And now I can just go to generic passives and select my resistor and check what the hell is going on here. So what is the position? 100 minus 100. So it is actually within 100 grid, which is absolutely fine. Same thing here. So why do we have the problem here then? This is... Oh no, it is actually correctly aligned. Okay. So maybe my experiments with... I don't like it. actually, maybe we need our preferences to be different. What if we do 25 mils? That's better in my view. Okay. So now, how do we do this? We need to remove this because now it will be here. And we need to add it to the line. It will not be meso anymore. It will be meso pulled up. Pulled up meso. Let's move it a bit lower. And the power symbol, of course. And to connect it. Looks decent enough. What the hell am I pressing? Oh, I press E, and E is preferences. Okay. Good to know. Now this is a new meso. And we need to do the same for MOSI. And how do we do it to look nicely? This will definitely not work. And this will not work. I can definitely put it here, but the point is that it's... Hello? Oh my, KiCAD crashed. And the crash is... Interleaved saves may produce very unexpected results. What the hell was that? And it's opened empty. Was? Okay, so everything crashed. Nothing works. Okay. I think this is a price for switching to the newest version of the software too early. Oh, okay. Let me actually switch category from software development to science and technology, I guess. Because people don't seem to be wanting to come to stream today for some reason. Let's keep going. Again, I'd say let's restart actually. It's already open. Where is it open? Like, it isn't open. Card all changes. My KiCAD is closed. Restore. The following files will be deleted when restoring the commit. Proceed. Okay, so do I have updated files here? No, everything is bloody broken. Fuck me. Nothing saved. Holy cow, this is so annoying. Oh, what was that crash? Holy cow. I'm quite literally pissed. Hello? Okay. Oof. But we know how to do it fast now. Update Close. Libraries were saved. Syncfully. Move it here. Polygons. Why are you so close on this layer? Okay. So we moved it. Let's check for errors. Run DRC. Nothing is an error. Check 3D model. They are fixed. Okay, let's save this time. Switch to schematic editor. A schematic editor is somehow saved. Okay. Sure. Whatever. Let's make this a bit bigger. We need more space for what we plan to accomplish, which is quite a lot of things. Not really, but you're going anyways. So how do I make it look nicer? Let's just make it first. This will be removed and put here. Like that, and this should be connected to these. Okay. Okay, this looks ugly as hell. So I think the way to make it better when we have two of them only is to just mirror, which is X, and just move them closer. And also use a single power symbol. This looks much better. This looks much better. Okay. And we can try to do a similar style change here. Though it does look worse when resistors are in this location, because we need to have these values on the same line, which depending on this value can suddenly start intercepting. But this is a change we would like to introduce. I think we also need to Google, do I need to use TVS on an SPI line? Whether I need to use TVS on an SPI line depends primarily on whether the SPI lines are exposed to external environment. They are, such as through connectors, cables, or user accessible buttons. While not strictly required for internal short distances, single board communication, TVS are strongly recommended for protecting sensitivity from ESD in industrial and harsh environments. External access LAN cables, if the SPI lines go off the board, connect to a screen or accessible by user, they need TVS diodes to prevent ESD pulses from frying the microcontroller or peripheral. Okay, that makes sense. That makes a lot of sense. Actually, let's chat GPT. Also, what else do I need to add to SPI line if it is connected to a separate PCB over cable? Okay. Over cable, it becomes much less optional. At that point, you should think in terms of signal integrity and protection. On the same PCB, okay. No, between boards over cable, strongly recommended, sure. Okay. A small low capacitance TVS array designed for high-speed lines can prevent random failures or damaged ICs. What to add SPI over cable? Series resistance, very important. Okay. 2 o'clock as well. Master in slave out. Okay. Slow edge rate slightly. TVS diodes. For all of them. Place them right at the connector, not near the MCU. Grounding, okay. Keep it short. Use twisted pair cable. This is a terrible advice because what will be on the other side of the twisted cable? Like twisted cable, how? If you just twist all the cables, you will get an absolute awful result. What the hell is this advice? Okay. Okay. Any recommendations for TVS array I can use? Also, do I need to pull any line up? Okay, let's start with this one. And this is from Texas Instruments, and we can just go for component search from there. All right. 4 channels. Okay, very low capacitance. Okay, working voltage. Okay, sure. This looks like a 2002 datasheet. Okay. Critical working voltage. Okay. MCU, series resistor, cable connector, TVS, outside world. Cable connector. What? How does it work even? MCU, series resistor, short trace connector, TVS, right as a connector. So it's on the MCU side. The goal is decurrent. Do need pull-ups on SPI lines. Driven by master, driven by slave, so pulls are not required for normal operation. Fuck no! In this design, we actually had problems because slave doesn't want to drive its line. So this is exactly what we had problems with. Miso sometimes, exactly. Optional pull up and pull down if multiple slaves share miso, or risk of floating line when no slave is active. Typical 10K, this is too much. Trust me, it's too much. Practical robust SPI over cable recipe. Fuse resistor close to driver, TVS array, its connector, pull ups, clocks, chip select. Sure, I think I do have it. Let me make sure. It will be not on this board, but rather on a motor controller board, which is this one. What? It seems like KiCAD 10 doesn't want to open multiple instances. What the hell? Okay. Oh no, I just opened the same file. Okay, I'm just a dumbass. My bad. This is the file we need. So let's check the schematic. Do we have chip select pulled up? Chip select. We don't. Why don't we? Why would we actually have it pulled up? If it's driven. Okay, sure, whatever. Okay. Maybe it's needed before the ICs are started fully, properly. Do I need to put TS on both encoder and motor and driver PCBs? You don't strictly have to put on both ends, but in many real designs you should. Here's how to decide without over-engineering it. The main driver PCB, this is capable of cable, is short. Everything is inside one enclosure. Okay. Okay, so I should do it on every PCB. Fine by me. Now let's look for the components. Sure. Do you have any newer versions? Because TI usually recommends better versions. Oh, it's quite an old component. So let's see. ESD protection diodes. 4255. What interfaces do we have here? I see. Packages, features, configurations. I'd say this or that. ESD protection. Oh, they are rather cheap, which is very nice. So it's unidirectional. Application, HDMI, USB, LVDS, DisplayPort, PCI. Okay. Family of international resistance pressure based on electrical discharge protection diodes with ultra low capacitance. Each device can dissipate dry exposure maximum level specified by AEC. Okay, international standard. Ultra low load capacitance makes the device an excellent choice for protecting any high-speed signal pins. Typical applications, sure. Okay, I/O capacitance. DC break voltage, ultra low leakage, sure. And what voltages can we work with? Can work up to 5 with no lower limit, which makes sense. It's a diode after all. So let's see what options do we have here. Is 5.5 PRWM. Okay. Something new and shiny. Peak pulse power is very slow. I/O capacitance. Okay, okay. CPT. Okay. I need a unidirectional because I have no idea why would I need bidirectional. So, okay. Pin capacitance is very low here, right? 0.5. It's also very cheap. And how many channels? It is number of channels 4. Okay. 4 channels, 4 channels. Number of channels. Actually, there are only 2 that fit the descriptions from here. They are both more expensive for whatever reason. What is the protection diode? What is the difference between this design and this design? Is it bidirectional? But it's unidirectional. Okay, I'm confused. I'm actually quite confused. I think I will need to read up more on TVS, the protection types and such. Actually, do TI has anything useful related to TVSs here, like in their knowledge base? Okay. Protecting automotive CAN bus system from SD or SD protection for lean. Best recommendation by interface. Oh, okay, okay. This is very useful. This is very useful. Oh my. Below are the latest recommendations for, this was 3 years ago, pretty recent. In electronics standards of devices for multiple interfaces that provide you EAC protection and paired with low capacitance that minimize impact bandwidth in the system. Please also refer to guide for... Okay, I love TI. TI is the best company there is. They just explain so many things so well. Okay, okay. This is something I would probably need to read up off stream. Unless people want me to read it on stream. So let's see. Antenna, analog audio. Okay. Battery management, no. CAN, display port, Ethernet, GPIO, HDMI, I2C. Okay, this is close to what we want. Okay. SIM card, USB. There is no section for SPI? Oh no. No. There is no section for SPI. Like, how is recommended capacitance even like derived? Like, what do you use for? What do you even use for recommended capacitance? Maybe the document explains, I'm not sure. So what is probably the closest one to what we use? Holy cow. Okay, and here, megahertz. I think I should just use the recommendation we got and don't think about it so much, because I'm currently most likely incapable of designing this properly myself, because I have no idea of unidirectional and bidirectional difference, and I don't also have an idea of what do I expect for the actually any other parameter. So, oh, this is exactly the one we have, but for automotive. Very interesting, and sure, it is on top of the list for whatever reason. So do they have any new products? They don't seem to have any. They don't seem to have any, but the capacitances here are very low. It says USB. This is what we have. And it doesn't seem like they have any other options at all, like any different options. What is that? Or USB interface, okay. Just for my curiosity. Section with 5 amps, surge rating, and this is a better recommendation, which is what we have. What is the difference between those? USB, HDMI, okay, SMP into high-speed interface. Okay, so they are very similar, but this is just a bit stronger. It seems. Okay, what's next? Okay, 11 picofarad is a lot. And also it looks as it is a different design. They look all the same. Let's just add this version and be happy about it ourselves. So let's actually check KiCAD libraries if they have anything like this already in place. So let's check KiCAD libraries. But first, let's save the project because I don't want to have a crash again. Let's save it. Let's save it. Let's save it. We did. So now let's go and look around. In the symbol editor first, do we have? We do. And this looks completely awful. What the hell is that? Does the IC have 10 pins? Did it actually have 10 pins? Oh, it does have 10 pins. Okay. It does have 10 pins indeed. Okay. Sure. My camera died. Let me start it. Very nice. So will this work? I don't like it much, if I'm honest. But now this is a good way to remember how I was doing what I was doing. So let's copy this. Copy. So where should we put it reasonably? It is it's not a passive component, it's a discrete component rather. It is a discrete component, right? Because generic passives yes, only walls, only like resistances, inductances, capacitances, and crystals, which is a passive component. And generic discrete or transistors of sorts, LED. Okay, so this is a discrete component then. Let's paste. So description is the protection of super speed. Okay, this is quite something. Fortunately, USB protection is enough for me. USB. I think it is not for USB though. Is it? Is it for USB? Oh, it is for USB. Okay, but it's for many other things. So saying USB and 3.0 as a separate keyword is not a nice thing to do at all. So now comes the hard part, which is making everything work. And remembering how I was doing this. So let's see, this is a transistor I use. Reference is Q, which is correct. Value is a very particular part number, which is how the KiCAD libraries work. Okay. Footprint is attached by default in my libraries, unless they are generic. Okay, and 3D model is not attached because 3D model is a footprint concept, of course. Of course. I see, so all the text is only to higher up shown. For whatever reason, those texts are also shown, but they're shown in a hidden way. Okay. Can I link a datasheet? I can, and it links exactly to what I was reading, correct? Correct or not correct? Correct. Okay, so this link is fine. Let it be here. Italic, nope, thank you. So this text is here. Let me find other ICs so that I can just check how it works. Opal ICs. And maybe it is an IC actually. Memory, digital. Nope. IC is embedded. Where is the power part? Oh, it's in different units. Okay. Oh, units in KiCAD are annoying. I remember now. I remember now. I remember now. So the datasheet is here, but I would imagine it should be here. I would imagine so. Okay, okay. Let's pretend this is what's needed. And what length do I use here? I use in length 100 mils. Because this is hella long. This is hella long. How does it work on a microcontroller? I see on the microcontroller. Still is 100. Alternative functions, sure. Y position, artificial right, directional, graphical style. This I see look awfully non-KiCAD styled. But on the other hand, this actually makes sense to be here because it's a passive component after all. I have many free leads. Okay, let's change it. I really don't like this. I really don't like this. Why is this so ugly? Why is it so damn ugly? 100. Sure. Now the text is too big. Oof. Electrical type 3, line, indentation right, visible, links, sure. Oh, and we don't have ground here. Okay. Alright, sure. Not the ground, but the power. Okay. How do I make this text on the right, though? I'm quite confused. Let me screenshot it and compare to what I have in the ICE. Okay. So this is how it looks. This is how it looks. Okay. But they are identical. Then why is one text here and one text on top here? At what point do I set this up? What the actual hell, actually? Hello? Why is this way and this like this? Hold on a second. Okay, let me add a pin. How do I add a pin? Okay. And how do I change? Bus. 3 directional. Let's change nothing. This is the same. This is the same. Why did it rotate? What is happening? Hello? Is it a property thing? Symbol properties. Show pin number. Okay. Where are my properties? Holy cow. Place pin names inside. Oh, now I see. Okay, so these are the properties for that. Okay, okay, that makes sense. That kinda does make sense. Sure. Yeah, but this is awful then. Holy cow. This is so bloody awful. This looks awful. SSG and D. I guess I will have to stick to whatever they have. G plus, D minus. But they are like identical, right? It doesn't matter at all which I connected to which. Right? Okay, so let's go back then to the original sizes. The original dimensions. 1400. But let's put it to the left. And this orientation. And this should be like that. What the hell? Okay. So this should be like what? What is going on? Oh, they have a grid line between them, sure. So this is how I expect them to be then. Okay. This looks a bit awkward. So let's put all of this then. This looks very awkward. You know what? Given how custom this thing is, might as well go on full custom. Might as well go full custom. So name first, then description, then datasheet. Name first, then description, then datasheet. Okay. Okay, so let's save it. And let's also, okay, a footprint. A footprint is important. T404E05. What's your footprint? What's your expected footprint? Oh, so it is here. Let me open it. Let me open it. Okay. So use on. Sure, let's move it to another screen and let's open our footprint editor. Let's start all our libraries again. Pin. So what options do we have here? Passives, it's not passive. Generic testing, test points, sure. Generic connectors, sure. Buttons and stuff, discrete. Okay, so this will be a discrete component then. And the name of the component was, the footprint rather was, it was use on 1025. 1025, this one. So let's copy it. Let's paste it to our discrete. Pass. What I've done. It has been modified. Discard changes. Now we need to make it work as our standard, which which uses dot instead of triangle. Triangle is nice and all, but it's not very universal. So I never use this. Instead of use my dot, this can be switched to a rectangle. Instead, I never use these lines. They are just useless, effectively. So let's go to our courtyard. Let's add a rectangle and add the courtyard. I'd say it should be like that, roughly. So now let's edit our layers. And how do I edit my layers? Normally, save changes, of course, here. Let's screenshot this because I will need this. Okay, and here I just, what the hell? General. So here I use 0.8 and 0.8 with proper signals. Here I use 0.6, 0.6, 0.1, and a custom user label user was. Where is my user 9? Okay, this is annoying. KiCAD. File, board setup. User layers. Okay, so file. Preferences, I guess. PCB editor. Colors. No. Footprint editor. Okay. Footprint false. Okay, so this will be... Oh, there are more user layers. Hold on a second. Was user layers. Okay, 9. Okay, now it works again because it didn't work before. So do I need 9? Because I use 8 and 9. But whatever. Now let's save it. Let's go back here. Let's see. These are set up. 127. 127 they are. But I also need this one. This boy. Hello, Warsaw. There is no everyone here. No one is watching me today. I'm so sad. There is only me, and now you. User 8. Okay. Orientation. Orientation is fine. But the size is a bit too much, I guess. A bit on a too much side. KiCAD font. Sure. How are we doing, Warsaw? Okay. Looks good to me. And the position of this thing should be like what? Save. Let me see if I have any rules, specific rules for position. I see I do have. I have a single grid line. Single grid line with grid of 1/10 of a millimeter above the object line. Okay. Okay. Cool. Sure. Happy that you are cool. How's your progress with your implementation? I think I use wrong layers. This should be 9. What? We're trying to remove layers, but I'm not trying to remove any layers, brother. Hello. Audio user. It is correct. Move it a bit up. Now it looks nice. So it has a 3D model, which is the default one. Okay. Whatever. Good, I think I did excellent job till now. It sounds like now something is absolutely wrong. Now things are very wrong. So let's save it, but how will I call it? I usually simplify my names. So let's rename it. And it will not have this. 2.5 per 1. What do you want from me? What's the actual fuck? Oh, I'm getting so annoyed by this error. KiCAD. Let's copy this. Like, how do I solve it? How do I solve it? You are trying to remove layers that are used by the footprint. Okay. What bloody hell? But I don't try to remove shit. What do you want? Is it not good enough? Oh! But I don't need a custom stack up, brother. I really don't. Like, what is that? You will be surprised when you see my layout. Surprised in a positive way or a negative way. And when will you show me your layout? Show me now. Oh, I have phone call. Moment. That took quite a while. So, what I was trying to do, I was trying to rename this. And it didn't want to allow me for some bullshit layer reason. Whatever. So what I wanted to test though, actually I want to see. Oh, I remembered now. What I'm using is actually different than one. What KiCAD uses by default. Which is okay, I believe, like that. This will be like this. This will be fine by my standards. And this we can put in here. Okay. Nope. This. Now, do I like how its component looks? I do. I just want to also make sure that the pin size is what exactly? 0.3 by 55. And the spacing of this pin size is okay. It's 0.5. Okay. So what is our description? It says pitch 2.5 per 1. It's a IC size, of course, but I don't need an IC size actually. It's given in the IC type itself. These are not important to me. Pitch is important and PDF is fine. Okay, so this means that it is fine. And now let's finally use it, right? Let's finally use it, but first I need to note for myself to do learn about layers, issue in libraries, and also another to do, make a 3D model for the TVS. Okay, so this is done then. And also here we don't need this actually, but we may need more of those, which we will use like that, which we will use like that. Okay. Oof. Oof. Okay. This should go here. I don't like this mode. On schematics, this should go here. This should go here. And oh my god. And here. Let's touch everything. Perfect. And now let's add our newly added component, which is TPS, if I remember correctly. No, it is not. What was the component I was working on? TPD. TPD. This one. Holy cow, is huge. And also it didn't preserve the styling I set for it. Which is annoying. Like that. Okay. This like this, like that, this. What do I do? So then encoder goes to high Z when not enabled. It's clearly mentioned in datasheet. Sorry, I'm not sure I understand what exactly you mean. High impedance where? Let me open the datasheet so that we can talk the same language. Show open with no, better show in System Explorer. Open MISO. What page? I see. But high impedance means what exactly? Data transfer starts with the falling edge. Cast, rising edge. Okay. As data transfer starts with the falling edge of CSN and stops at the rising edge of CSN. Clock is the serial port clock and it's controlled by the SPI master. It is high. There is no SPI transmission. MOSI master output slave input is a serial port data. Keeps high Z and its driven data is shown in the figure. High impedance is the same as floating? Is it? Is high impedance same as floating? Oh. Oh. Okay. The more you know. The more you know. So I guess, yes, I guess it was set in the datasheet, but I didn't know what to make of it. And given that in datasheet itself, they don't propose to use like a resistor here at all, and in like their later schematics as well, like they never use a pull-up resistor. We got like so much noise because of it. So much noise. So where the hell was I? I was here. What do I do with not connect pins? Texas Instruments, please tell me. What do I do? Any recommendations? Any recommendations? 0. You recommend to just put through. Okay. You recommend to put lines through, which actually makes lots of sense. But it also requires me to redesign connector, which also makes a lot of sense. Why not? Why not? Okay, so then I will need to know where is what, where is which. Okay, okay. Anything else? Was? So this is supposed to... Okay. So D1 to pin 10, D minus to pin 9. Okay, okay. Okay, sure. Sure, okay. What improvements you are doing to encoder board? I do line resistors for all lines that are 0 by default, but we may want to change them to something later when we have the board. I also do a pull-up for MISO, and I do a TVS array for all the lines. So then this will look like this. This IC looks ugly. Let me use a new feature I discovered, which is grouping. Very nice. Very nice. So, hello. What is the hotkey? W. W. So this will be like this. Before, right? Not after. CSN pull-up to make sure it's not enabled. Why do I need the CSN pull-up if I use GPIO to drive it? I'm not sure that I need a pull-up there. What? What is that? Okay, this is awkward. An awkward way the grouping works. Okay. During boot. That does make sense, actually. It does make sense. And then do I use an open emitter output instead of just output? I will need to experiment with this, I guess. But let's add another one. And another one. This IC looks annoying. It looks annoyingly big. Let's increase size. Move over here. Move this up. And connect this and that. And this and that. Or actually, you know what? No, I think I'm a dumbass. I think I'm just dumb. I need to switch the pin out of the connector to facilitate this. Actually facilitate this. So let's remove all of this. Let's remove all of... Hello, brother. Where is my selector? I don't want to select pins. So ground now will be on pin 5. And then we will have this here. Holy cow. Holy cow. Okay. Move it down. Connect. We'll move up. And up. This will be connected to each other. They all actually will be like that. We just need to figure out what should go where. Calibration enable, sure. This will go. My God, I keep pressing wrong buttons here. So this is ground, sure. So this IC is actually bidirectional, so it doesn't matter what orientation we put it on. So do you think SPI is a good choice to do board to board in noisy environment? It is definitely not a good choice in a noisy environment, but this is the only choice I have given the IC I use. And if I were to, for example, change SPI to CAN or something similar, or like RS 485, I will have many more components here, which will make the board way more expensive. I would say that my environment is not like super high noise, and this setup should actually solve all the issues. At least this is what I hope will happen, because it might as well not. And if it will not, then then I will suffer the consequences. Then I will, of course, suffer the consequences myself as a reliable human being. So let's do it like this. Let's select, actually, let's do it like that and select like this without you. Without you, oh my God. Holy cow. Tracks only. Oh, yes, the order changed. Fuck. Sure, and you go. Oh, yes, of course. Now you all go to the resistors. Sure. Was. Okay, so. But before we decide how to do it, let's see which pin goes where. Dimensions. Nope. It's graphics. Print. Yes. So let's see. We will center it around here at the same coordinate that this pin is at. They should have the same center, which is, what grid do I use? Whatever it was, I don't like it. 107 and 90.7. And where is my origin? My origin is in the middle of the IC. Okay. Is it? No, it isn't. Bus. Grid origin. Point, no. Real face file origin. But this didn't change. Like, where is my actual origin? It is somewhere here. But why is it here? I think at least you put buffer on driver lines for encoder one channel to overcome line capacitance at high speed and no need to pull up or MISO at all then. And what do you mean by buffers? Like, what kind of buffers? It sounds like a complication to me. Why are my coordinates messed up? Where do I even supposed to have them? At. Is it broken on the other driver as well? Now the coordinates here is correct, but the display is incorrect, I see. So display still thinks we are working here, even though origin is set to be here. Okay. One channel FAT bus switch. Single high-speed line switch. The switch is disabled when the output enabled, input is high. The device is fully specified for partial power down application using I-off. The emerging current will not backfold to the device when it's powered down. The device has isolation during power off. But why? Why would I do this? First, I'm sure this component is not cheap. Like, it's not resistor chip. Like, it's 16 like cents when you buy 1K, and resistors are like actual 1 cent. They can be cheaper than 1 cent. So like, what do we win from using this exactly? To ensure high impedance state during power up, power down. But high impedance is like exactly what we have on the IC itself. And high impedance is like bad because high impedance is floating, which is what you just made me Google. But the line will be driven like high and low quickly. Won't it be? Like, I genuinely don't understand why would I need this. If I can drive my bus high quickly enough by just having a pull-up resistor of a small, with big enough value to not draw too much current. Like, I don't think I will add it for this iteration. So let's see, his location here is 107. And this location is 90. Okay. Let's make it a better value. 91. And 91. So our first line then will be our... These lines are not named now, but it will be a 7th line as a connector. 7th line as a connector is CSN, should be first. So this should be connected here. Oh, hold on a second. No, it should not be connected there. It should be connected here. Then this will go like that. Okay. Then this will go like this. And this will go like that. That should make sense. Now encoder will suffer in low because of pull-ups that you don't need when master didn't enable the encoder. What do you mean encoder will suffer? Like, I don't understand what encoder suffers means. And what do you mean will suffer in low? Like, low what? Like, what is the suffering and like the pull line low? But why would it suffer? Because like it will have a pull up inside it anyways. And when it pulls down, if there is a pull up resistor, then the total resistance will be lower when they are parallel. And if there is no resistor, but like just a driver circuit, then like it still will not suffer because like this is how like pull-ups work. Because yes, it will be slower, but it will be still fast enough to drive the line with the speed it should drive it, because like we measured the rise time. So it will not suffer to pull the line low, because like we measured it, we measured the time, and like we selected the resistor value not out of thin air. And that's why I'm confused. Like, maybe putting this IC in line is like a good solution, but it's definitely not a necessary one. Unless I am a complete dumbass, of course, which is also possible. So let's save this. And let's go to PCB and update it. Okay, ground B. Oh, I see. No, I don't like this. I should move it. I should move it up by millimeters. So I should move it up by 1.95 then. Okay, this was a wrong direction. 225. Also wrong direction. 89.75. Right direction, but it doesn't seem to be aligned. 0.5. Oh, that looks much better. So let's remove this and that. And let's try again. Oof. Oof. How do I move it? Okay. Okay. Nope, this is better. This is direct connection, perfect. This should be directly connected. Okay. How do I switch? Let's see. This. Normally Miso is driving the line up down with no interference from any pull-up pull-down resistors. It should overcome the short line in both cases. Now you make it harder to send zero. I literally don't make it harder. Like, no, I do make it harder, but it is harder within a reason. It's harder within specification, and it's allowed. And like, for example, the motor driver has a pull-up like that has to be done. Like, they do recommend the pull-up, and they recommend a 10K pull-up. And like this is what I do in the motor driver. Like there is a pull-up, and this pull-up was too heavy, it was too hard, it was too strong, as you said. And that's why I moved it to 1K, so that it's fast enough. And this is on the misaligned, and this is the datasheet recommendation. So I just decided that I will do the same for encoder. Align all of this. And what's next? How do we look in height? It's small enough. It's small enough. And what is our bottom? Bottom is ground, right? It's full ground. It is full ground layer. Okay. Okay, and unfortunate because I need 3.3 volts here. Let's put all inline resistors first before I start thinking about it more. Oh my god, just remove all of you. Holy cow, this is annoying. Oh my god. Please. Thank you. So, what? This is a line resistor. Sure. This is not a line resistor. This is a line resistor. Sure. This is as well, and this is as well. So I need to stack them and align them. And I also need enough space to be able to manually resolder them if needed. Oh, let's switch from this view. Oh no, this is awful. Let's actually just do this. But in the datasheet, it also recommends TVS on power line. What recommends motor driver? Which of the ICs are we talking? I would like at least 2 grid lines, maybe 3 actual grid lines between all of them. The encoder recommends TVS on the power line. Oh, it does. Okay, this is true. I don't actually have it. This is a true statement, but I'm not sure why you use bots. Like what's the point you're making? Are you making this point to make, like, to indicate that I should do another change as well? Or, like, how should I understand this? Are they aligned against 985? 88.6, which is 1.1, and this is 90.2, which is not 1.1, which is like this? No. Rather like that. Oh, wait a minute. I'm doing this wrong. And this is, oh, now they are aligned. Okay. Now I can make it like that. Okay. Now they are still aligned. Yes, and align this and this. Perfect. Now everything is aligned. So okay. Let's rotate everything correctly. Of course. Let's also add a via here. Oh, the via will not fit here. What is the size of this via? The size of this via is 0.3, so yes, it will not fit. Yes, better improvements, especially the board cable is next to motor coil power. What's better improvements? Adding a line driver? Moving lines in KiCAD is unpleasant. I'm just too used to moving lines in Fusion 360. So will we have unpleasant polygons here? We don't. Perfect. This one also is annoying. Let's remove it. TVS. On power, you mean? Yes, I think I should add it. Sure. I just need to look up a component, proper component to do this. What's datasheet said about the new chip you add? Like, what do you mean? Like, which datasheet? Fine. I will move this later. Here. And yeah. I need to connect this to 3 volts. How do I do this? Just directly, I guess. I don't have another choice. Pretty much. Like this. And do it like that. Ground via close. Ground via close. Okay, this is the first one, and I will also need to do a second one. But it cuts this line. If I make it shorter, can the via fit here? It can't. It can't. So but if I put a via here, it will make yes, place here, which I don't like at all. I saw some kind of lines protection previously. Like in this one. Yes, I do protect lines because lines had noise. Not the power line, because power line was actually rather stable, but all other lines had noise, and like you saw it, we were measuring it on the oscilloscope. You were there, we were seeing a lot of noise. Go to hell, line. What are those? Stop. So how do I do this? How do I do this? Actually, I don't think I have an option to decide. What said? Like the datasheet for it is like 30 pages. What exactly is your question? Like it is a 5 volts TVS diode array used in high-speed communication protocols. If you need the datasheet, like this is a part number. Okay, and how do I move the 3 volts there? Well, technically I have 3 volts here. Right? I do. Okay. It is low capacitance. It is 0.5 picofarads. Okay. It's rather nice. And here. Does everything fit? Yes. Oh, I see. Yes, I need to get this one. Text. Dollar. Device. Configuration. Not device, but design. I like that. And also screen. Oops. Oops. Like that. Like this. Pass. Pass. Okay. Okay, okay. This is here. This is rather, I make it center aligned like this. This one should be also center aligned. Like that. And this is fine. It's fine. Let's see. That looks nice. Also, this is a wrong footprint, which is fine. Wrong footprint in here. And to change this, I need to go to the library actually itself. So this is a footprint we want to use, but where is our symbol? This is a symbol we would like to use it on. So properties, change the symbol to use on and our symbol. Save, close, save, hide, update, tools, update symbols from library, update, okay, here, pull changes, update, close, perfect. No unnecessary silk screen. No unnecessary silk screen on the board. That looks much cleaner. Also, why is this and that have different font? What? 0.8 and do 0.8 as well. Oh, I see. I see the problem. I see the problem. Fixed. Now let's do error check. 4 errors. Item shorting 2 nets. Oh. Uh-oh. Uh-oh. And rather... Okay. Pass. Okay. Like that. Sure. Let's do it again. No errors. No errors for me. Let's remove this. Let's remove this. And where is the block draw rules area? Will be a very small one, an area block zones. Block zone fields. Just like this. Zones. Floor. Why is it not selectable? Oh, it's a rule area, it's not zone. Okay. Like that, so we don't have our ground pip here. Also, this looks awkward. Actually, you know what? I think I should do it like this, because there is actually space if I don't do it like a dumbass. There is space for a via. And I can do it even better. I can do it even better. Okay. All right. This is better. So let's save. Let's save, and let's open the datasheet. Recommendation. They don't seem to. They just want me to put any TVS 6 volts. Okay, TVS 6 volts power line. Okay. I need a unidirectional one. No, but this is not what I need. What I need is to actually find the component number. TI, TVS diode for connected world. Less than 12. Okay. But this 6 volts in the datasheet, does it mean clamping voltage or the breakdown voltage? Multi-chip application is shown in the figure. Okay. Do I have any recommendation? By single supply, so decoupling capacitor no less than necessary for better AMC performance. We highly recommend adding TVS between VDD and ground. Default reference circuit is shown. Okay. So no, they don't give a recommendation. They just say 6 volts. All right. What is VRVP? VRWM is maximum. Yes, you are correct that I use 3.3 volts. My question is how to select TVS diode. I came across this document. Okay. The reference working maximum voltage. Reference working maximum voltage. The reverse working is defined as the voltage that can be applied to TVS diode with an assurance that the diode will not overprocess or temperature conduct significant current. The definition of significant current depends on the TVS manufacturer, but generally it's 100 nanoamps. Enables the design to select a device that will see minimal leakage across all operating conditions. In design, should be selected to ensure that it is above the expected maximum operating voltage. Okay. If the applied voltage rises above this threshold, there is a chance to see diode leakage increases significantly. For example, if the protection line operates at 5 volts and nominal with a maximum variance up to 7, ensures that 7 or greater. Okay. I don't understand why the last sentence is exactly... Understand that if the voltage rises above 7, the device will die. So if I choose a TVS with a nominal, as noted in the last sentence, ensures that it is 7 or greater, and the voltage goes to 7.5, my interpretation is that the diode will not conduct significantly. Okay, that's a good question. The key word is operating conditions. In the example, the device is 5 volts nominal, but it can withstand 7 volts without immediate damage. And it might occasionally see 7 volts supplied. Then the TVS should be selected so that it doesn't conduct 7 volts. Okay, should be chosen somewhere in the zone between the highest expected supply voltage and the voltage that causes damage. If there isn't any margin between those values, then you have a problem that TVS won't fix. Reasonable? Reasonable enough. So where were we? We were here. TVS diodes. Why are they so thick? TVS diode for 3.3 volt line. Power line. I have a PCB with 3.3 data lines and power supply lines. Both require ASD TVS diode. Is the bus I have used. Okay. Diode for both, but I feel like this is likely not a good idea. The power supply can have up to 2 amps. Low capacitance. This line are the same voltage. Is the problem with doing this? This won't fire unless the threshold is reached. The question becomes, what kind of abnormal voltage do you expect on a 3.31? If it is ESD, a TVS applied to it will be dissipating the same energy as it hit on the data lines. If there is a possibility of overvoltage from the power source that needs a different type of protection, very reasonable. Assuming overvoltage isn't a problem, then using the same TVS for data in power line is fine. Okay. All right. Then maybe the reasonable thing to do is to actually where is my PCB? Oh no, I opened the wrong thing. My PCB is here, so maybe I just use one of these lines for power instead. Do I need it on all of them? Maybe I can actually skip chip select and use one of the channels on the power. Because chip select is the stablest of them all, I'd say. Because adding like a separate, is there a version of this IC that has 5 channels and not 4? A question, a food for thought, So TPD, this, that, this. Let's go here. We were here. Okay. So 3.6 volts. And how many channels do we have available? Let's see, 5 channels. Haha. Haha. There is no IC for 5 channels. Should I actually use this one instead? Because I currently put 5 volts one. I currently used the protection 5.5 volts. Number of channels. Oh, there is a version with 5 channels actually. But it looks awkward. Use 6. What do you mean use 6? 6 volts or 6 channels or what? And what filter? But why would I use an 8-channel IC? It will be an overkill. It will cost a lot of money and will also take a lot of space. Actually, what I wanted to check is actually to check the datasheet. The datasheet and to check the recommended footprint. Recommended footprint. So it does recommend this to be to exercise. Because sometimes those are less cost if used by common design. What do you mean? You mean that if I will use them in many designs, they will be cheaper for me because I will buy more? I think this footprint is actually wrong. Because this should be 0.2, this should be 0.4. This is 0.3. Oof. What is hell? KiCAD, why is your default footprint sucks? .55, they recommend 6.5, okay. All items, pods. So let's actually change it to the datasheet recommendation. Where is my properties panel? Let's say 57. And the position of this one, -385. And the correct position. Okay, this is the position of the center, right? Oh, it is a position of the center. And the position of the center should be according to the datasheet. According to the datasheet, it should be this, which is okay. 0.535 divided by 2 is 4175. Okay. So KiCAD default footprint is lying to me. 5 or 6 may be higher cost than 8 because maybe all people use 8, so it manufactures a lot and its cost is low. Oh, I see what you mean. I will check it. I will check it now. I will check the price when I fix the footprint for this one. And the same for this. 3, 4, 175. I just love this feature of KiCAD. And the spacing and between them is 0.5. So this should be here, 0. This is correct. And these two, oh no, these 4 should be 0.2 actually. Right? And these two should be 0.4. Okay. If I were to use a default KiCAD footprint, I would have messed my design up terribly. It's a good thing that I thought to check it. Okay, save. Save and saved. Now let's update our PCB file. Let's update it here first. Tools, update. Move to the PCB, import changes, update. What's an error? Cannot update U1. Footprint not found. Was. What do you mean footprint not found? What do you mean? Should be in IC slitted. Like here. Here it is. Footprint found. And it has a direct link. Maybe it's not connected here. Let's make sure. Oh, I see. Yes, it is not found. Because it is here now. Okay. It's just too old of a design. And let's push the changes. Now we don't have errors. And now we can update it and check for errors here. And unhandled exception occurred. Press abort to terminate the program. Try. Fuck! This is the second time today that my KiCAD crashed. Fuck. Like, what's the actual hell, KiCAD? I think I switched to 10.10 version 10 KiCAD too early. It has too many bugs. I don't like it at all. I should probably go back to version 9. Or this becomes very annoying. It's already running, but it is not running. Oh, that's annoying as hell. So let's see if it's saved anything. Let's see if it's saved. Actually, no. No errors here. Tools, update. Okay. That's all right. No biggie. We saved before the crash. Okay. So what were we talking about? I was fixing the footprint and we were talking about prices for TVSs. Let's see if an 8th channel one is cheaper than a 6th channel one. So where were we? In diodes, 5 volts, sure. Let's open this one. It's an 8th channel one. It's actually the only 8 channel one. Oh, I will definitely not use that. Let's use. Looks awfully unusable. And also that looks kind of expensive. Or is it? Oh, it is very expensive. No way. No way, brothers and sisters. Show more. Oh, this is a relatively cheap one. But also the body sucks a bit. Does it? I really like this one. I really like it's incredibly pleasant to do this. It's just incredibly pleasant. You can just put it like that. I just like it so much. But we still need to put a TVS to the power line. But also, back to the question. Let's check this price. 0.3. Quite a lot if you ask me. But this has a nice case, this one, that allows the similar approach. Allows the similar approach. So what is my choice? My choice is to actually put CS out and power in. And to also switch voltages from 5 volts to 3.6 reference voltage. So let's do one at a time. First, let's switch schematic. So we don't need CVS on chip select. I hope. Chip select was the most noise immune line in our tests, so I hope it works. Okay, no, like this. And instead, what we will do is we will put this onto the 3 volts. Onto the 3 volts. Let's see, like this. Do you agree, Warsaw? Or is it not the way to do it? And here we should switch this to a very similar component that has 3.3 volts. SNL 65 over the 14 is a highlight positive for today. So this is a multi-channel transceiver for SPI over LVDS. Sheesh! $3.5 per 1K unit. Oof. Oof, this is steep. This is very steep. Okay. Okay, alright, sure. No, thank you. This will cost as much as my whole encoder. So let's see. Now I need to update. And this will break, of course, which is fine. And instead of being here, what will happen is that I need to do it like this. And how do I put 3.3 volts here? How do I do this? I think I use this channel then, and I use calibration pin here because it's only occasionally needed, and it's no, I cannot, because otherwise I will mess up these lines. But I can also route it like this, so let's do it. Let's actually do it. What do you not like? Why power line is not thick? Why should it be thick? Like there is no current. Don't be paranoid if you have like 10 milliamps of current, you don't need a thick line. You don't really need a thick line if you have even half an amp of current. What I wanted to do is to switch those two. Okay. Let's save, and let's save all the time, because otherwise we are risking another crash without saves. So let's pull our changes. Now, this line should be deleted. And here as well. Let's delete it for now. Do this. So this will go here instead. This will go lower. This I need to delete as well. I don't think I should put it close to the AC, but I can now put it like that. And nicely into the ground. To look nice. Oh, I see. That's a good reason. So now I need to switch my lines again. I need to switch my lines again. Also, no, I don't like this actually. Actually, thinking about it, I don't like that. And the reason is that I would like to do this. Because I would like to do this. Because I need it here. Okay. Move it to the side. Why? KiCAD, why? Okay. Like that. Let's see what happens to the polygons. Quite a terrible mess happens to the polygons. So let's move those out. Remove this, and let's move this in. And then let's put it like this. And actually, let's write routes through this. So let's remove that and remove this and route. Carl has weak pull down. Does it? Are you sure? There is a constant speed to pull up. Automatically calculate. Pull down. Pull down. Okay. Well. Pull up call to start. Keep the system rotating. Sure, let's actually start from the very beginning of the document. Calibration. Auto calibration enable digital input. Pin searching in the picture. In which picture? Was non-linear user calibration. Follow chapter and from styles. Okay. Calibration enable. Chapter 9.2, okay. Chapter 9.2. Calibration. Here. What even is the value I'm using actually? 10K, okay. Where is a pull down? It is not a short. Why do I use it? Who knows? At this point. Okay. Figure 5, it's inside the chip. Let me pass. Oh, I see this. Oh, I see now. Okay, you are correct. And why did I even put it into my design? I don't remember at all. Okay. So you are correct. You are completely correct. What is happening? Oh my god. Oh my god. This value can be higher as well. Say 220. Okay, so I don't need this. This is a very interesting suggestion. Thank you. Thank you. I missed that completely. Okay. You are correct for some, and I am stupid. And I am just stupid. So what now? Now I need to shuffle all of that. Oh, that will be annoying. That will be rather annoying. But it also means that I can do this. Move it to the side. Remove that. Looks good to me. Move this to the side. So now I need to put it here and this here, and I need to move ground to pin 4. I need to switch pins 4 and 5. Switch. Okay. Okay. No, stay up. Okay. Like this. And let's update the PCB. This update takes longer than I expected it will take. I never use those kinds of sensors. Do we need calibration at start or just alignments? And neither. We don't need it at all, and I don't use it on my driver. Like I don't even have a pin for this, because this calibration is supposed to be done like separately with a separate setup, like special calibration setup, not the motor itself, because you need a separate motor that will spin your motor. So this is a bit harder, and I didn't put it on the boards, because if I were to calibrate it, I will need to do it like with a separate board. Sorry. Oh, I also forgot to update this. Sure. Okay. No, this will actually stay. It will just stay lower. Lower. This should go, this should go, this should go, this should go. This should go, this should go, this should go, this, this. And you will move to 88.5. No. Zones, hide. 91, okay. Okay. here. Remove this and that. Add a via to ground. So what the hell? Oh yes, now I need to rearrange all of it. That's annoying. Okay, so let me screenshot it for reference. Let's go and rearrange all of it. But let's also save because KiCAD crashed twice today. And let's remove all of this and let's think about it. How do we have to do this? So based on our screenshot, we need to use net 1 to connect to, which is pin 6, to connect to our clock. This will be pin 2, so wait again. 6 should go to 1. 6 should go to brother. Six to 1. 5 to 2. Let's check. 6 to 1, 5 to 2, correct. 3 to 4 and 2 to 5. 3 to 4. 3 to 4. And this will be the power. Okay, let's check. Let's save, of course. Update, and let's see. Yes, that looks rather nice. Rather nice. So now we put our power through a diode. Let's move ground for a moment. Yeah. Okay. Okay. Sure. Too many ground vias. Move it down for beauty reasons. Oh, the reasons of beauty. So 2 points here. Like that. And like this. Perfect. We also need to rearrange our resistors. Or do we? Or do we? That we actually do not. Hello. Okay. Oh, I think this is misaligned now. No? Yes? Yes, no? It is misaligned now. Okay. Rough. That looks about right. Sure. And let's move it here. What else? What else? This connects directly. This we should move. And we can actually move it down. Can I use 3 volts here? How do I make my 3 volts go all the way there? Let me think. I need to remove some of these because they are annoying. Also, oh, the seal screen's here. Okay, sure. So, oof. I don't know. I don't like the snapping in KiCAD. It annoys me. I don't need any VS here anymore. Let's switch layers. Remove this, go back, remove this temporarily, because now I can do it like that. A bit nicer. Nice enough. Also thinking about it now, should I somehow find a way from here to here and not like this? Given that this is a TVS here. On the other hand, do I need to find a way there? I don't think so. Let's remove this and that. For now, remove this as well. And I'd say put it here, because I'm a bad boy. And the bad boy has a terrible idea. Terrible idea. So we are here. We are here, we are there. We are everywhere. And I need 3.3 volts via, let's say, roughly here. This is better. I also need a ground via here. Ground via. This works. This works nicely. Then I can do like this. Relatively beautiful. Okay. Switch layers, make it shorter. The shorter the better. The shorter the better. Then this will go like this. And another ground via here. Why not? Okay, this is a bit annoying, but I believe I don't like it actually. I actually don't like it at all. I quite literally rather not break the ground layer here at all. I rather not do it. So I rather do it like that. You better not. You better. Oi. 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 What I've done. Rotate. Rotate. Like this. Good enough, I guess. Okay. And then we do it here. And a bit closer to this. This will not break our ground polygon under all our traces with their return passes. And given that we have 10 megahertz, we don't want to break return passes at all. So I'd rather do this. Okay, this is too close. We have space. Plenty of space. Okay. Okay. Good enough, I guess. Will it work? Will. That works. That works. That works. Oh, I need to remove this line. Hold on a second. I don't like you at all. Where is my... Oh, this one. G&D. No. Zone out. One. And like this. Stay away, demon. Here. Make it nicer. In all the edges. In all the big edges. So here. 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 Now I don't like this line actually as well. This line now doesn't make much sense. Rather use ground layer. Rather use ground layer. Okay. Like this. And then I need to add more VS here just to be sure. Nothing terrible will happen from this. And also make stitching nicer. Make the stitching nicer. That's unnecessary via. You're also unnecessary. Move those closer. Okay. So let's see, do we have any errors? Run DRC, we don't. Very nice, let's save to make sure. Update is going up nicely, it looks very good. All the vias are closed and they are 0.3, which is fine. Do we need to do anything else? Do we see any other problems on the PCB? Silk screen looks fine, right? Silk screen looks fine, version is updated. Okay. Okay. All right. So then our update is done, and now we need to generate the manufacturing files, I'd say. Right? Or wrong? I think so. I think the update is done. So let's make sure. No, let's also make some notes. This must be on the controller, or rather master side. And I need to remember what text to use, text color to use. Let me open my schematic for the motor controller because I have a unified styling that I forgot. Actually, let me do a 2-minute break. 2-minute break. before we continue. Be right back. Okay. Kiwi fruit is eaten. Ha ha ha. Take that, kiwi fruit. This must be on the master side and align. Actually, I remembered two things. One thing is that I need to update this. Update this to 3.6 volts version. Let's make color annoying. To not forget, of course, to update it. And let me open my other design, which is, yeah, what? KiCAD 10, what is happening? Okay, let me open it from file system rather. Not this. Where are you? Yeah. Oh, there is no errors. I use lines. Okay, sure. And what is this color? Is predefined. This one, okay. Slightly less annoying. Bold and less annoying. Okay. So this, a line? No, a line that should be angled at any angle. Hello. And this is a pull up for our chip select, and this should be on the master side later when we update the master. All of them should also be on the master side. So let's add a rectangle. Hatch. What? Oh my. A dash. Okay. Let's add it like this. Without any fill. Okay, and actually make it a bit more presentable. This should also be on the master side. Why is chip select on the master the encoder side? What's the difference? What is the difference? Update to 3.6. So let's go and find 3.6 version. Hello, Texas Instruments. Not this, not that, not this. This is correct, but not exactly. This is what we currently use. Okay. To not flow in the destination site. I'm not sure I understood your point. What do you mean exactly? Not float in the destination side, but like whenever you put it, as long as it pulled up, it's not floating. So 3.6, we have this guy, little guy, and this guy is the same guy, correct? It does seem to be absolutely the same guy. And what is the capacitance? Of course, 0.25, and here 0.5. Oh, it's actually even lower. Very nice, very nice. So let's switch. I would imagine that it's just a naming switch. But given the way KiCAD works, let's create another symbol. And let's real quick check the datasheet footprint. It's the same. And let's real quick check the description. 0.5, USB 3.1, sure. Very nice, very nice. DC breakdown 5 volts, okay. But what is operational voltage? Input pin voltage. Reference standoff. Okay, so 33.6. So let's add it to our libraries in KiCAD. One moment. Uno momento. Signore and signorito. So, switch. Add to our libraries. Where are we? Symbol editor. Symbol editor, full screen. Was no. You unstart all my libraries. You did this to me. But the action to not float is at an encoder side where the source of noise probably start. It will pull chip select up before reaching main board to overcome it. This is how I understand it. But no, this pull up is not a noise pull up. You said it yourself. Why are you changing your mind? This pull up is a pull up so that the data is not transferred when we are at power up. It is not related to noise in any way. Make your mind, Warsaw. Make up your mind. So let's remove and reopen, and let's hope it's saved. It did. So now let's quickly do our discrete. Copy this. Can I duplicate it? Yep. And let's just simply rename to that. And also we need to add more letters. More letters, please. And the letters are GQAR. Good enough, I guess. Good enough, I guess. What day is today? Tuesday? Wednesday? Tuesday. What year is today? I have a problem, maybe not a problem, but sometimes I forget my birthday. The year I was born, I forget my age. Which is awkward. Sometimes I don't remember how old I am. And I'm bloody old. U06 DQA R. Okay, sure. And here. Okay. They use the same footprint, but description should be different. No, it's not my birthday today. I just forget. My birthday is... Where is my birthday, actually? What month is today? It's April. Oh, my birthday is in half a year. In half a year, I become even older. How old are you, Bursa? For channel, and this will be 4.4 volts. And how is the, what is the name, right, correct way to call this voltage? Let me open TI website. This voltage is called RVM. RVM. RWM. And we will need to do similar change to the second one. Old enough to not drink, so you have a story of your life with drinking issues. Tell us more. Okay. And here, let's also change it. We need to add this parameter, but it should be 3.6. Okay, this is here. Correct. Sure, looks good to me. Looks good to me, right? Yes. And now what do? I save it, I close it, I go to my design, and can I switch the component? Change symbol, okay. And I would like to change to this guy. Change. Was? Oh no, hold on a second. Change to what? What the hell? Change symbol. Oh, new. I see. I'm a dumbass. So this is new. Change. Okay. But it didn't change. Was? Whatever, I will just re-edit. I will just re-edit TPD. This one. And no! So like this, save, push the changes, update, close. And this should be connected, located like this. What is the snapping point, brother? Yep, this is correct location. Save, run GRC. Very nice, very nice. Check the serial model. The seal screen looks good, nothing intercepts. Very nice, very nice. Final checks, final checks. Stitching looks nice. No, it doesn't. And what am I here? Do this, do that. Looks good to me. I think we are done with the redesign and we can proceed to Gerber file generation. And also, what I spent 2 hours yesterday. The server did come with encoder, but encoder was different, and I used custom encoder. That I removed an old encoder and I used this new encoder because I wanted encoder of my design as well. And one of the reasons for this is actually I tried to communicate to the the default encoder. It just didn't work well enough. And now with my own design, I can like control everything, and I also can like spend countless nights debugging it, which is also fine. But yeah, we have what we have, and we don't have what we don't have. I don't know. It's actually epoxy glued, so I have no idea what's the IC inside. But I can maybe disassemble it. But I actually don't really care much. But if you really want, I can do it for you. If you really, really want, I can do it for you. Do I need any other comments? Okay. I don't think I do, right? So let's save. And now let's work on our exports. So what do we need for production? I would like to order boards that are built in China. I don't want to solder them myself. So we need, let's see. We need to plot our schematic and Gerber files. So include layers, okay. Courtyard, backyard, yard. I think default is fine. Plot drawing sheet, sure. No. No, drill mask, none, scaling. Gerber option, coordinate use extended, recommended. Not recommended, okay. And where is as the origin? Use drill place file origin, yes. So I want to pan you. Okay, so generate the real files, sure. Desktop temp, nope, this is a bad location. Gerber temp. Yes. Generate. Plot. Close. Let's see. Let's see if it worked. Let's see if it worked. D work here, 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 and here, and here. Was? Oh. I saved them to the folder of the wrong project. But whatever, let's actually now use KiCAD integrated Gerber viewer. And let's check the Gerber viewer. So here is the viewer. So let's go one by one. Outline, sure. This is paste, sure. This is silk screen, sure. This is mask openings, sure. Top layer, sure. Bottom layer, sure. Bottom openings, sure. Bottom silk screen, sure. Bottom paste, we don't have any. Openings and vias, drills. Perfect. This is perfect. Now, let's actually automate it, because I spent quite a lot of time to be able to automate it to my standard, and I would like to test if it works correctly, so you all will bear with me while I struggle. Now, yesterday we read the changelogs. Actually, I read the changelogs for KiCAD 10 offline, off stream rather, and KiCAD 10 changelogs were very underwhelming compared to 9. 9 had incredible amount of very interesting features, and 10 was like very underwhelming. And more so, even like 10.0.1 crashed twice today. And it's kind of annoying. I don't know what happened. They said they had more contributions than ever, more work done than ever, but like less features, less updates, and it works terribly. Not terribly, but it's kind of messed up. So let's create a new job file, and let's call it M1E1 job set. Job sets, job set. Save. And the folder will be different. We will use outputs folder. Select. I would like to use a relative path. Replace. A relative path is very important here. So it's move one level up, or two level ups. Actually, let's see. So this is a job set file. So one level up, then outputs, one level up, then outputs, and then our M1E1 I dollar. I hope it works. Design iteration dot outputs. Okay. Let's see if it works, and let's start with the simplest one. Let's do a PDF PCB, but not PCB, rather a schematic. And output directory will be default. Default, right? Yes. Okay, and let's try to run it. It's run, and it worked! Let's remove it, and let's run again. It works! Okay, so perfect. Very nice, very nice. It works. It really works. So I can just change iteration in my variables, and it will just create new folder every time. And this is very useful. This is incredibly useful. Oh, and I will show even more tricks. I think this will be quite an interesting guide on how to use it effectively, efficiently. So let's rename. I actually don't like the name of this file because I have a standard as well. This will be called $design iteration schematic, right? Is this the way I call them? Is this the way? Hold on a second. Don't peek, don't peek. Okay, here, and here, and here, and here, and let's say here, schematic. Yes, I just call it schematic. Okay, so let's try again. Let's remove this folder. Let's generate. Yep, just 3. This is an error. It should be I3. Save job set, generate. So we also would like to generate our Gerber files. We would like to generate our Gerber files and pick and place files. So let's do it one by one. But first, let's do the most important, the most complicated, and the nicest part in that. And this is, let me show you actually. Let me show you, because yesterday I was fiddling with this. Yes, this is an example. Let me open the folder. I need to copy my Python script, which is here. So let's copy the Python script to the here. Let's use VS Code. Let's use VS Code and let's update the Python file. Let's actually rename it first. It will be M1 E1 for now. Rename outputs. So, okay. This is our first rename. Then we will do the same we will do the same multiple times. Actually like this. So, nope. Nope. Was. Rename project file. Rename schematic file. And rename PCB file. So let's switch the names to the proper names, of course, which is this. Nope. This. And also let's change the endings. One is pro, one is SCH. And also PCB. Save. Looks good to me. Nothing else here for now. Let's actually edit here to our KiCAD job set. So we need to do the copy, special copy files, and this file that we copy will be first this. We need to edit multiple times. Copy files PCB and copy files SCH. Let's first test that it works in general before continuing our work. So great. Perfect, they were edit. Remove them because I would like to have them renamed, and that's we can do by running custom command, execute command. Let me actually check out the command I prepared in the yesterday. Execute command. Okay, this one. So Python, this script, sure, but it's named differently for now. How did we name it? M1E1 rename outputs.py and designation. Okay, and let's generate again. Let's see if it works. It does. What is that though? I don't want a log. No, please don't. And it's empty. The hell? Let's remove it and see if it will generate it now. Nope. Very nice, very nice. It's automated. It's automated. Close current tab. So, oh, where the hell am I? What else do I need? Gerbers and pick and place. Let's do it. So add PCB, Gerbers, export Gerbers. Output directory will be M1 E1 Gerbers. No, E design iteration dot Gerbers. Oh, do I need to select them manually? Do I remember this? Oh, that's unfortunate. Let's actually go to the PCB file and see what we need to select. Let's just copy all of these settings. Screenshot. Go back. Here. Edit settings. And let's see. We need this and this. This. Boom, bam. Beam, boom, bam. Bam. Tutti-tu, pa-po-pa. Not this. This. Use both file name extension. Tell. Nope. Okay. So let's test if it works. Can I archive files using command line? Actually, interesting. I actually think that command line doesn't work properly on Windows, so I need to do it using a Python script. So maybe I will do it later, because I will need to write a Python script to archive all the files in the Gerber files folder. But for now, let's test if this works. Our automation works. Remove, iterate, open, Gerbers. It works. It works. Very nice. But we also need cut files, which are not generated here, right? And I don't even have an option to. Do I have another automation to generate drill data? Okay, perfect. Output folder is together with Gerbers, M1E1, I, design, iteration, Gerbers, absolute. Okay, let's actually save the job set and see what the setting is in our PCB file. When we plot and generate drill files, let's make a screenshot. Okay, let's make a screenshot and let's see what we need to change. Go back. Where the hell am I? Yeah. Edit job settings. So origin, drill place file origin, sure. Millimeters, of course. Zeros decimal format recommended, sure. Gerber X2. Not this. And not this, but this sounds like it's useful, but let's do it like this for now. Save job set and let's try to test it again. Let's try to test it again. Great. Gerbers, iteration and iteration. Okay. Very nice, very nice. Automation comes up nicely. Let me add a to-do in my personal to-dos. Learn how to make a Python script to put two archive files into .zip. So what else do we need? We need PNP files. Pick and place, of course. Pick and place. And how do we do that? Let's go here, plot, Gerber, nope. How do I actually do pick and place? How do I do pick and place? Actually, I don't remember. KiCAD, how to generate PNP files. Pick and place machine is different. Here is no standard way to create a file-specific machine. PCB file application output position can be used to generate a file. Hold on a second. No, there is an automated way, right? Because I have it here. Top pause, bottom pause. Oh, there are. Okay. Actually, do we have any options in the KiCAD itself? Plus 3D model, which we will also need. Real data, TXF, CAD, Kerpers, IPC, ODB, PDF, position data. Position data. Design variant default, output file, M1, E1, I, dollar, design, iteration, PNP, format, CSV, units, millimeters, include only SMD footprints, no, exclude all footprints with through-hole paths, actually, yes. Include all footprints with through-hole paths, exclude, no. Exclude all footprints with the do not populate flag set. Yes. Exclude all footprints with the exclude from bomb flag set. Let's not put it, but probably yes. Okay, use the real place file origin. Yes. Use negative X coordinate for the footprint on the bottom layer. No. I think this is how it's supposed to be done. Let's try it. Let's see. I think the PCB manufacturer provides plugin to export everything the easy way. This is a very terrible assumption, no offense meant, because by this you mean for hobbyists when you work with like PCBWay or Easy IDE, but like there are thousands of, not thousands, but hundreds of PCB manufacturers, and most of them do not provide you anything. You need to give them Gerbers and the whole set of documentation yourself. So from this standpoint, you need to automate the generation of files. And yes, I can definitely install a plugin to do it, to, like, for example, generate for PCBWay or GLC PCB. But also I need to store them in Git, like all these files in Git, for reference in case I will need to order like older revision of the board. So that's why I'm doing it. And like this thing actually saves a lot of time in the future because I will just need to press one button. And I really like this feature. I just need to remember what and where I need to press for all of this to work nicely. So let's remove this, generate this, and let's see. Oh, that didn't work. Was? Out file. PNP. UAE. PNP. Dot CSV. No. How do you expect this to work? Oh, okay. I see now. I see now. This will be M1, E1, I, dollar, design, iteration, and whatever. CSV. save, and let's run it again. Let's run it again. Okay, I got lost again. Here. Remove this. Generate. B. Nice! It works. It works. Okay. Very nice, very nice. Oh, I see. My renaming script is incorrect. Incorrecto. It should be I here. Now it is correcto. Okay, do we need anything else? Do they have... What else do they have? Export SVG. Actually, quite interesting. What will it do? Let's say... let's do it like this. And let's see what it will give us. Plot drawing sheet, subtract solder mask from seal screen, indicate. Let's just see what it does. Then perform DRC, PCB render, and what will this do? Oh, I see. And it will save it as a PNG. Okay, let's try. Let's just try everything. Export DXF, no. Netlist, no. PostScript, no. SVG, no. Yes. Bill of materials is important as well. And it's important to automate it. Reference, value, footprint, no datasheet, no description, quantity. Why do they not populate it automatically? Rough. Let's first see what those do. Command, perform RC. So yes, this is the last one we will need to set up properly. So let's save and then let's run the job and let's see the result. Oh, it took quite a while longer. Oh shit. Okay, let's see. Okay. That's rather nice. Actually, this is very nice. Hello? Actually. Hold on a second. Let's render PNG. Edit job settings. PNG dimensions. Okay. Transparent. Add floor, anti-aliasing, screen space, ambient. Side view. Okay, though there is no way to remove components. If there were a way to remove components, it would have been so nice, but given that there are not, this is actually not that good. Just once. So this is what just generated, which are separate layers, as I see. Okay. This is not useful, at least for me for now. So I will delete this and let's edit this. Appearance, settings, legacy colors, follow PCB editor, follow plot settings, follow PCB editor. What will this change? Let's see. Let's see. G. This changed nothing. Okay. Okay. Actually, now thinking about it. Oh, my camera is almost died. Has almost died, but not quite. Now thinking about it, I would like to go to the 3D model view of the project again, and let's see. For example, let me remove all the components. This considers as SMD was okay, like that. And now let's say I would like to change the view, right? Export image. Can I zoom to zoom? Can I zoom to fit? I don't think I can. Last render time 1 millisecond. Sure. Use ray tracing, but I don't need ray tracing. What I need is zoom to fit. No, this is not zoom to fit. Okay. Let's say. No, let's say 800 by 800. Sure. Let's see the result. Where was the result saved to? Actually, no, but I don't. But I don't need this. And one E1 redesign files. Okay, replace. Sure. Here. Oh. So I can get a nice image if I just know the sizes correctly. And what view do we have? I need to change to see the board. Oh my god. Orthogonally, preferences, was. Oof. Oh, so I see it orthogonally, okay. But now that when I export, oh, the board is okay. I see. I'm just a dumbass. I'm a dumbass. So pixels, because board is not a square. Board isn't a square. It's 3 by 27. Okay. Okay. So it will be, let's say, 900 in width, and 27 will be 810. Okay. Let's try again. And what do we get now? The picture. Was? What is that? No, but why this? I don't need this. I said what I want. No, why are you using this? Stop right there. No, no, I don't want this. Please, brother. 810 900. Save. Again. And go here. Okay. That's much better. But the board is not aligned. What is happening? Okay, so I see the workflow. I don't think it can be automated, but sure. And why I was doing this is I wanted to see how hard it will be to get the picture of the bottom and the top of the PCB, like specifically cut to angles, to use as a texture, to apply this texture as a picture, to this picture as a texture to the 3D model of the PCB in like mechanical CAD, like Fusion 360, to have a beautiful looking PCB without it looking like a green goblin. Okay, so then this is useless. This is useless in our setup file, which is here. Delete, save, and now let's work on our bill of materials. Let's add bill of materials. Okay. Actually, now, actually, nope. Save. Okay, let's generate it. Hello, by hands. Let's screenshot it. I do believe that I have a field that is not represented here for whatever reason. That is not represented here for whatever reason. But okay. So close for now. And let's go here. Let's edit job settings and let's see our screenshot and just copy the screenshot values. So it was bam, boom, bam, beam, dish, bam. Okay. Boom, bam. Nope. Boom, badam. Boom, badam. This is comma. This is that. The reference delimiter is comma. Nothing here, nothing. CSV. And out file will be called m1 e1.i dollar design iteration dot bill of materials. Default. Oh, there are presets grouped by value. I see. Oh, I see. Oh no. How do I go back? Sure. Okay. So let's save and let's see if it works. Let's see if it works. I got lost again. Here. This. Generate. Let's see the folder. Where is the folder? Oh. It doesn't have a proper ending, so let's change it. Let's save it properly. So here, settings.csv. Okay. Save. Did I remove it? Did I remove the folder? I did not remove it. Generate. Folder. Open. And let's see. It works. And now I remember the issue. I remember the issue because footprint names are useless for bill of material generations. They are needed in bill of materials, but the library preset is useless for them because, like, why the hell would the manufacturer need your library name, right? And I don't think there is a toggle option. Hey, but how are we doing? Pretty fine. Automating KiCAD output file generation for everyone. Everyone can do it to build a proper versioning for your PCB designs. So this is what we are doing right now. So we automate all the generation with a single click of a button. And now that I remember this, I need to go and look at my components in the library, actually. How are you doing? How's everyone doing? So here, not here, let's go to our, actually let's go to a different view. No, not a different view, editors, symbol editor. And here, let's open, let's say, genetic passives, resistor. Oh, hold on a second. That's annoying, actually. Footprint is here. How did I do it before? I'm sure that I've done it. Let me open my other project. I'm sure that I've done it. Somehow. Let me check. Nope, this is not what I want. This is what I want. Datasheet value. There is value, okay, but the bill of material is a property of a schematic. So have I done anything specific here? Footprint. I haven't. Okay, so I only had an idea how to fix it, not the actual implementation of how to fix it. Let me see. Is there an option to remove library names? Group by value and footprint, default editing, attributes, no. Edit. Can I remove this? Okay, this will break actually the file. Got changes. Okay, so the way I propose to solve it is actually a bit of a manual labor, but it's better than doing it manually later. So let's, maybe it actually can be automated. Let me think. I think it can be automated. It can be post-processed. We can just write a Python script that will remove the first part of every single footprint name until the double dot. So it's actually, I think this is a better solution than, or is it actually a better solution? Hold on a second. Okay, I was talking a lot to myself. Let me show what I'm thinking about. So the issue is here, we have a name of the library and the name of the component footprint, and we would like to only have this part. And removing just this part will work, but it will only work for me because I have custom footprints. And if, for example, you are using your default KiCAD footprints, their names are like terrible. They are called in terrible manner because they have too many letters. Let me show you. And this is not what your manufacturer needs. Velvet Whisperer, I guess, left without answering my question. Okay. So, let me close all of this. For example, we just added today a component, which is, this one. And this is as USA on 10. So if I look for this in the libraries, there is a version of this, of course. but like these are the names. And your manufacturer will have no idea what it means. So this approach with removing the library extension will not help, because like you will still get a lot of garbage. But it will work for me because I have custom libraries for everything I use. So I actually just need to write a script, Python script, to look through footprints table in the CSV file, and to just remove all the first lines. Actually, we can try to wipe code it very fast. I never wiped code it on stream, so let's actually try it. Let's try to do it. Now let me call in our cloud. So let's wipe code it. So what I need is, please take a look at the .csv file and write a Python script to remove library extension from the footprint. Is it called footprint? And what is correct name? Footprint, yes. From the footprint column. By extension, I mean the part before this. Let's see. Let's see how fast it will achieve us the result. Prefix. Did I call something wrong? Oh, yes, it could have been called prefix, just prefix. Python script footprint library. Bomb clean, it's fine. The footprint column, case sensitive, strips everything up to each row. On each row, okay. Rows without this are left untouched. Sure, let's see the script. Let's see the script, what you've wrote. Oh, that's a bit more code than I expected. CSV, sys, okay. Strip footprint library. Also, why don't I have a Python syntax highlighted? I don't have it installed. Hello? No, I do have it installed. What? Okay, that's awkward. Okay. Input pass, string, output pass, string, none. Sure. Okay, it returns none if length of system arguments is less than 2. Input usage, Python, input CSV, okay. And output CSV, okay. If output CSV is emitted, the input file is overwritten. Sure, this is fine. Okay. If length equals more than 2, else none. And if none, what? Actually, not sure what this means. I will ask later. So pass, input pass, output pass, if input pass is else, okay. Open, encoding, sure, as file, dictionary reader, okay, rows list reader, field names, footprint column, okay. Okay. Is footprint column. Okay. Found in pass name return. Okay. Row in rows. Value. Footprint column. Okay, row at footprint column. Okay, sure. Split. Sure. Open new line. Okay. Fly. Called field names. I think it makes sense. Let's try. I think the script does make sense, so let's try to run it. And let's actually try to run it from the... First, let's make sure that we have our semicolons yet. Close the file, don't save. And let's run our script. Python strip hello. What the hell are we? Okay, Python strip. Okay, and the input name rather is M1 E2 I3 bomb. Okay, it doesn't work. Thanks, Claude. Oh, I'm a dumbass. Oh my god, that's CSV. Did I mess it up? Oh, I did mess it up. No, I didn't. Did I? Did I mess it up? Clear. Let's extend it. Not you. And you a bit. And the command is this, and the file name is, and the uno file name. What is our file name? Oh, do I need to put it in the parentheses? Nope. M1 E2, I see. E1 E3. Okay, I'm just stupid. And footprint is clean now. Okay, so it works. That was easy. Perfect. And I actually need to remove datasheet. It's in, or do I actually? I think actually datasheet can be useful. Datasheet can be useful. Okay. Perfect. It just works. And let's actually add it to our automation. So let's move it out of the outputs into here. And let's call it M1 E1 strip library.py. It doesn't need to be M1 E1, but we will move it later. So let's go to our automation pipeline, which is here. Generate bill of materials. Sure. And after this, we will need to run a execute command. And the command will be Python run keep mode, and then our M1 E1 strip. How is it called properly? Let's just copy it. .py, and the path to the file will be job set output work path, and it already has slash, so it will be m1 e1 .i $design iteration, dot bill of materials dot csv. Okay, so let's see if it works. Save job set. Let's remove the folder. This one. Okay, try. But I don't have it open. Hello? I don't think I have it open. It's not open here. Or here. And what I'm trying to do is I'm trying to delete this. Then I'm trying to delete this. Oh, I have... What? Oh, I do. No, what? What the hell? Whatever. So let's see it's populated, and let's see if it has... It doesn't. Ooh, it works. What has no manufacturer part number? What do you talk about, Warsaw? Our automation works. Hooray! Hooray! Automation works, but I don't need a log. Let's put it here and update Encoder PCB and prepare manufacturing files. Yes. Automate file generation. Yes. All of it is done now. So let's delete this. It's open in Excel, but oh, I see. Let's save. It's open in another program, but no, it does not. Oh, maybe it's open here. Oh, it was open there. Okay. Port BOM file need to have part ID. What do you mean? Let's generate it. And let's see. Wrong folder. Now it's stripped. So reference value. Datasheet, not very important. Footprint, it's important. Quantity. BOM file need to have part ID. But reference is a part ID, or what do you mean? Like, and the value is name of the component for ICs, and I think this BOM already has almost everything. Just for usability, it can have fields like THT or SMD populated. Like, this will be useful. But other than that, like, what do you mean by an ID? And this is definitely not needed to be edited. It will be useful. Talk to me, baby. Aha, aha. Let's try it on GLC PCB. I never ordered from GLC PCB, I believe. But let's try it. Can I order without making an account? GLC PCB. Services. Let me create an account then real quick. Sign up. Sign up with Google. Continue. One moment. USD. Okay, whatever. I'm not from US, but whatever. This works. No, thank you. So order now. No count, I think. Still don't understand exactly what you mean. So 2 layers, dimensions, they will update it automatically probably, but okay, let's say 27, 10 or whatever. Okay. One design, single PCB, PCB thickness, default, let's say black, silk screen, right, material type, sure. Hustle works for me. 1 ounce works for me as well. Centered, yes. Non-specified, whatever. Sure. Will this actually change the price? Oh, it does. Holy cow. I believe PCBWay doesn't change the price with 0.2 anymore. Good enough. Remove mark, order number. No. Both fingers, no. And no. Edge plating, no. Blind slots. Oh, hello? No, I don't have any of this. UL marks, no. Assembly. Please upload Gerber files. Okay, sure. Let's see. We generated our Gerber files. Let's just put them into the archive. This will be here. No, i3 Gerbers. Oh, now I think I need to rename all of them to have iteration version as well. We will fix it quickly soon, but let's just put it here. I think they will be fine. I hope so. I hope they are fine. Oh, now it's updated. Okay. Now everyone knows that I live in Poland. Sheesh! So, assembly. Very good, very good. I need to assemble top. Economic, sure. What's the difference, actually? Okay. 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 So, bake components. Okay, let's go one by one. Assembly side, top side. PCB quantity 10. Tooling cost added by GLC PCB. Sure, do it. Do it yourself. Firm part placement. I think it's easy enough that I don't need to do it. Stencil storage. Oh, if I need to reorder. No, I don't need it. Fixture storage. No as well. Parts selection by customer by GLC PCB, let's say. No baking. Clean will be nice. Special stencil, no. The panel boards and natural before delivery, no, because I don't have a panel. Flying probe test, of course. Okay, economic doesn't do it. But this is very important. It is very important. Okay. Functional test, no. Photo confirmation also is not available. Holy. Conformal coating, cleaning included. Also is not available. Packaging. Anti-static bubble wrap is fine. Solder paste. High temperature. Sure. I don't mind. I'm not working on anything that should be certified. For now. Nitrogen reflow. Sure. No. So they haven't asked me for bill of materials yet. Well, let's say next. Add bill of materials. Okay, let's do it. So let's see. I'm not sure if it will work right away, but let's just add it. Okay, I need to select it. Let's go here. Bill of materials. Product description. Sensor. humidity, liquid, oxygen, current, circuit control, battery, electronic clock, distant measurement, instrument, kinda, multimeter, thermostat, no, 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 no. Distance measurement sensor. It kinda is. Let's say this is the most applicable probably. Assembly notes do well. What is CPL file? Pick and place files. Okay, sure. We already also have them. And I am assembling top, so I only need one. Okay. Accept only essentials. I agree to terms and conditions. Part sections by GLC PCB requires sensor. Ooh, that's quite expensive actually. But okay. Submit. Let me fill it off screen. This is personal information. Let's say I do this and that and this. Poof. And this. Why do we need states? Not every country has a state, right? What do I put as a state? Holy cow. Postal code. Okay, you need it like this. Sure. Okay. Actually, okay, I like it. Anyways. So mobile phone. Sure. And here. I think is almost done. I need to Google what do I put into state. Oh, I see. I'll put this one. This line here. Now let's save it. No thanks. Submit order. I agree. Oh, but I need to pay for it, but I don't want to. Oh, no. Okay, so I will not test it now because I don't want to pay for the order from GLC PCB. Actually, I would like to order from PCBWay. I just have much more experience with PCBWay. But at no point in the process we were stuck with our bill of materials. So I'm not sure. Like, do we need something to add something here? Like, do we not? I think it's good enough the way it is. Because we have reference values, we have, actually I think I need to, oh yes, we have a few fixes to do. And what were they? First of all, we need to add a space here. So let's do this real quickly. Bill of materials, edit job, space. Nope, not here, here, perfect. So this is fixed. And another thing we need to fix is our Gerber generation. Because I would like this to be... Oh. But I don't have an option to do so. Do I? I don't. Okay. Unfortunately, I cannot rename them. Unfortunately, there is no way I can rename them unless I run a script to do so. So the same thing here, I would imagine. Yes, same thing. I cannot rename them, which is fine, which is absolutely fine. I also thought I needed another script for what I forgot already. What's the help? Did I say something about needing another script? Oh yes, for archiving. So let's actually use Claude again. Why I closed it? Oh, I remember why. Can you please write a script to... The point is you need part number or manufacturer number so that you assemble the right parts. Not exactly. When we are talking about passive components, putting in generic is usually good enough, because when you put in generic, actually, maybe you are correct. One moment. Let me see. I think you are correct. Like, we do need to provide through-hole and SMD and also a part number. But this part number can be generic for SMDs when you don't need to specify what you want, because like they will use whatever they have available at that point. And here we do need to specify like specific numbers, and so this will work like this. And this we can actually add as well. So let's do it. Let's do all of it, given that we are doing the PCB design anyways today mostly, and also some vibe coding. So let's actually solve both of these issues. But first, let's solve the issue of archiving. And yes, GLC PCB definitely has a lot of parts on them, because I think GLC PCB owns the LCSC. So given that they own the site, they have like a huge selection of components, because LCLC is actually quite a great website for parts ordering. So I would imagine that GLC PCB has a good selection. I would be actually very surprised if they hadn't. So, and the script was Claude script to archive all files in the .gerbers folder. Please write a Python script. And let's see. While it thinks, I think it should be very fast, so let's just wait for it. If it was longer, like given that the task is very simple. Folder relative. Okay, I think I messed it up. Okay, that works. That works fine. So let's see the code. Let's see the code. So finds all. Oh, find all dot Gerbers. Okay, sure. Right. Okay. And the zip is placed inside the folder and named after the folder. Okay. Existing zip files inside the folder are excluded from the archive. Perfect. Very nice. So import zip file from passlib import pass, script direction pass file parent. No, I actually would like this to be arcv1 2. Arcv or arcv. No, it doesn't work like this. Hold on a second. How do I do this exactly? Let me look up my other script. sysargv. Okay, sure. Sure. Import sysargv. Oh no, but it will be 1 because 0 is the name of the file itself. So script direction, Kerberos direction list. Actually, I'm not sure that I'm a fan of this. What is that? What does this do? Glob given relative pattern recursively. This is like calling past glob is in front of the pattern. Okay, but I don't need this. I really don't. If Gerber there is, if not Gerber there's, sure. For Gerber there and Gerber there's. No, I don't like it. I don't like it at all, actually. Let's switch it up. Oh, it's haven't finished, actually. Uh-oh. Uh-oh. Can you please change the file, change the script to get a path to the folder as a console argument instead of searching all the folders as a logic with putting everything but other archives into the archive is good. And also, what was the solution? And saving with the name of the parent folder is also good. Okay. Yes. Works. Both relative and absolute. Okay, let's see the script. So archives all files in the given folder into a zip named after the folder. Existing zip files inside the folder are excluded. Usage Python archive gabers.py pass to folder. Okay. If okay, sure. Here press there, resolve, sure. Okay. Very nice. For F for F in Gerber height. Okay, sure is file and suffix isn't zip. Perfect. We just remove all the zip files. Very nice. If not files, okay. No files to archive. Sure, that works. Zip pass gerberdir name dot zip. Hold on a second. Zip pass gerberdir name dot zip. This line may work incorrectly, but let's see. With zip file dot zip file zip path write compression zip file zip deflated, whatever this means, SGF files f write arc name print f plus f dot name. Not sure what this means, but this is probably output to the console, just output. What? Oh, I see. It will just print two spaces plus and as if it wrote a file. Sure. Okay, that looks simple enough. Let's test it. So Python. No, let's first do list system files, and now Python archive gerbers.py, and the name is M1 E1 I3 gerbers. Okay, let's see. Let's see if it works. Where the hell am I? Not here. Okay, there was an archive. Let's do it again. Did it work? Oh, it did. And now let's put this file here. Let's rename it. Let's rename it as M1E1 archive gerbers. Oh, we're building quite a library of automation scripts. It's just great that all of them are simple enough. So, but now we need to try to use it again, but as a part of our automation pipeline. So let's do it. Let's go to our outputs, remove this. We can't because we have it open in Claude. Let's just remove all the files. Close this again. Don't save. Remove. And now let's add an automation step and let's see how it works. An automation step. Let's add execute command. For now, we need to move it out of gerbers generation here. Edit. So the command will be Python $keep project mod this M1 E1. Let me just copy the name. This script, and we need to put the input as $job set work path. What else? M1 E1 I $design iteration dot gerbers. I think this should be correct. But we also need the real data here, so it should be like this. Let's try to run it. Let's see if it works. It didn't. Error. What the error says? It says is not a valid directory. Is it not? Hold on a second. Oof. Oh. What? What I've done. Maybe I need to do it like this. I'm not sure. It's empty. It's empty again. Doesn't work. This stage. PCB design files. User. Why do I have this part in here? Python this and then that. But this is correct. No? Yes? Maybe slash should be different. Backslash? Nope. Edit job settings. Work path M1 E1 I. Are we in correct location? We are. Use relative path. Why? It's worked before. It works on another script. Why should I change it here? Why should I change it here? Oh, it worked. I just removed. Okay. Okay. I think the semicolons, no semicolons, brackets, bracers. What are they called? Quotes, double quotes, were not needed. So let's see if it worked. Remove this file and also make sure that we don't generate it. Edit job, record, save job, Gerbers, and we have an archive. Yes. It all works. It all works. But we also need to do the same for our PNP files. So let's copy, or actually, can I duplicate? Yeah, so we can just add new one. Execute command. Let's rename it for visibility. Description. Execute command. Create Gerbers .zip. Here is rename design files. This command, what does it do? What do we do? Description. It will be clean footprint names in bill of materials, and this command is what we want to do now, and it will be create pnp.zip. Let's see. So move it up. Let's copy this because it will be almost identical. Add but instead of Gerbers, it will be PNP. And now records, please. So let's delete everything. And let's generate. Everything works. We are the champions, my friends. Oh, and now I can do it in a single click. Oh, this is so nice to do all of it in a single click. Holy cow. This is so damn good. There's a sigh of success. Okay. And I can just copy this job set file to every folder because it's a text file, a JSON text file, and I can just do little changes to names of project, and it will just work. It will just work. Nice. That was quite an accomplishment. But I think we should do it even better than this because automation it never stops. So what I think we should do is to actually move all of those Python files. I think I should have 3 here. Yes, to a separate automation folder and call it from here because those are not project related at all. They are KiCAD related because I can use them for every single project. I just need to provide a project name. So we will do it, but if no one minds, I'm a bit tired. I would like to go and buy myself a snack, which will take me 5 minutes because I have a shop just under my home. Like we can stop here for now today, or I can quickly go buy a snack and we can continue. Decide. Okay, what? Okay, we stop, or okay, go buy snack. Continue, sure. Then I will be back in 5 minutes, and for now, enjoy the music and the motor up close. I'm back and I'm enjoying my snack. So now, first we have four scripts, and we need to understand which one of them depends on project name and which doesn't. So let's see. Rename outputs. Rename outputs does depend on names, so we need to update it. So this script doesn't, as far as I remember. Let's see. Let's see. Nope. Here. So I think I need to do rename from Gerbers to general archiving. Okay. So here we will definitely need to implement it. Hello. Provide additional to be a to-do console argument to use as file names. Okay, this I can do without NAI, and this this works without a name as well. So let's start moving. So my idea is what? I would like to be able to simply copy this file and do like the most minimal change possible to achieve the automation of this we implemented. Because I don't want to go through every single one of them and to change like manually every time I create a project. And I know how to do it. Like I believe I have an idea. So the main idea here is to actually add another custom variable and work from there. So let's do it. Let's go to the project. Sorry for munching. I'm enjoying my snack. So text variables. And let's say project prefix. And for this particular project, it will be M1E1. And I will specify those for every single project coming forward. So, okay. And now let's switch all our automation scripts so that we rely on this variable and not on a hard specified parameters. So let's go to our automation and start from the first one. So here, instead of this, we will use $. I forgot the name. Fuck. Got too excited. What was the name again? Let me copy it. Project prefix, I guess. Yes. Now I remember. Right before I looked up. Okay, let's go back to automation and put it here and this. And now we don't depend on anything hard about it. Save. Let's test right away. Let's test right away. Outputs 3, remove, generate. What the hell was that? Yes, we have our schematic. Perfect. So now let's just keep doing this for every single file to get an incredible automation. Here. Oh, this will be annoying actually. Is there actually a define for project name? How do I look it up? Project name. Let me Google. KiCAD, is there a text variable that stores project name? Okay, let's try it. Let's say like this, and let's save, and let's test. Let's delete all of it. Do you have KiCAD CLI? Like, it should come by default. I think I can just run it from anywhere. But it worked. Perfect, it worked. It worked. But why would I need KiCAD CLI for? Like, I believe it's somewhere here. So let's keep going. And let's keep munching. The same here. The same here. And now the first obstacle on our way to success. On our way to greatness. Let's overcome it. And for that, let me get all my scripts and actually move them out. And move them out to my repository that holds all KiCAD libraries. Here. Resources, and let's say automations. Move the scripts here. And now, what do we do? We succeed. So, open this. I need to copy one more thing. References. Pass this one. Okay. What are you doing? What's that? No, don't crash. I've crashed. No. Oh, it isn't crashed. If I want to do this kind of auto, I will use Python to call KiCAD and not KiCAD call Python. Just ignore this after reading. Yes, I will ignore it after reading because the job sets are specifically designed to do it this way. And calling Python from KiCAD means that you need to open the CLI and do the call, and it's some different sort of automation, but I can literally copy the job set file to any project and it will just work after we finish. It will be incredibly useful. I will prove it. Like in half an hour, we will have it working. and I can just copy it to literally any project because all my projects have the same structure and it will just work. This will be amazing. So let's keep going. I copied what I wanted and why I needed it, because I wanted to specify the path. Okay. And also we will need Claude. No, we will not need Claude to do anything. We will do it manually. This one. Project prefix will be sysarg v2. Also add error checking for argvs. And here what I will do is, oh, I saved them wrong way. Oh, oh no, I need the project prefix and project name. Okay, whatever. Console arguments will forgive everything. So here, project name, and here project prefix. And do the same thing here. And here. Just don't forget to put F. Pay respect, of course. Let's see. Looks good to me. So this is done. By me personally. Okay. Looks good. Let's now update the script. In my experience with Excel, I used to do script work with an Excel for automation, then I see it's way better to do scripting from outside of Excel. Yep, can be the case, depending on what you know. Because I believe a lot of people do Excel automation without knowing outside programming, like general programming. So it can be understood why they use Excel. But if you, for example, have a programmer background, it may be much easier for you to do it using Python or something. So both approaches work. I don't think there is like a correct one, unless the situation is very specific. Okay, so where were we? We were doing automation, not here. No, it's crashed. KiCAD crashed third time today. Fuck. Fix your stuff, KiCAD. It's crashed again. Restore. No. No. Where is my job set file? Was? Here it is. Was? Hello? What? What do you mean? It's right here. What? Could not find item? Where is my file? Motherfucker, no way! No fucking way, you are kidding me. No fucking way KiCAD just deletes my automation file. I will be so mad. No fucking way, brother. Ah. Fuck you, KiCAD. Holy fuck. What is that? Where is my file? It just doesn't exist. What the fuck? It just disappeared in front of my eyes. Hello? I'm not mad. I'm not mad. I'm chill as a cucumber. I'm cool and collected. I'm not gonna explode. Oh, fuck me. Hold me, someone. Fuck! What was fucking that, KiCAD? Holy fuck, it actually deleted my job set file. I was working on it for like 2.5 hours. Hello? Okay. We start from scratch. Fuck. Fuck. Fuck, we did so much. I hate it. I hate it so much, actually. But we had to redo it anyway, so... I will drink myself to forgiveness. Okay, whatever. Let's do it. So destination path. Nope. It will be. If not empty, it's. Stop laughing from at me. I was so close to greatness, and now this happened. KiCAD crashed third time today. Okay, so double dot slash project. Okay, now I forgot how I called my fucking KiCAD, brother. This is so annoying. It deleted all my work in 2.5 hours. And given that the file was saved separately, didn't move what outside? Oh, bloody annoying. Dot out. Puts. Pi files are saved. Pi files are saved, but the job set file is completely gone. It's gone. It doesn't exist anymore. It is gone. RIP. Job set file. Rest in peace. Rest in peace. But what do we do here? We never surrender. We had issues harder than this. I rage quit it once. Like, I'm not stressed. I'm just upset. So let's do it again. Let's do it from scratch. Because we can. And also I will start pushing to Git more often. Do not lose the progress. So it works so well. Okay, let's keep going. What do I need to check? I need to check how I call the folders. And where can I check it? Not here, not here, here. I have all my files. I have a reference of what I need to get when it will be ready. Okay, so outputs and then outputs again. Sure. Outputs slash this project prefix dot I dollar design duration dot outputs. This is the folder that we want our results to be saved in. So let's start with the easiest one, which is export PDF. Sure. So output directory will be as decided, as given. Schematic size, I think all of those can be kept default. Okay, and let's save this and run it to see if it works. But for testing, let's actually change our prefix to 4. Even though 3 is correct, I just want to save the folder with 3 as reference. So let's change our text variable to 4 temporarily. So everything is updated to 4. Let's save and let's go back to our automation and let's try to generate and see the results. Generate. Worked. It worked, but I need to also change the name. So let's edit. And the name will be project prefix dot I dollar design iteration. Okay, save, do it again. We go again. Don't give up. Generate and see it works, but I forgot the right name. Job settings. It should be schematic. Right. First step is done. First step is done. 14 more to go. Save job step. Push to GitHub. No regrets. Let me actually push to GitHub. Oh crap! I have so many updated files. Let me select what I actually need to push. One moment. I will do it off screen to not leak my email. I need to push the job file. Jobs file. Not this. Test by no. not this either, and not that. What the hell is this? I need to delete it completely, actually. Not this and not that. What the hell? Change log, KiCAD job set. Okay, I found it, so I need to do this, that. Oh, we actually forgot to update our changelog. Let's do it. We actually forgot to update our design changelog, which is here. What's in backup folder? Can you find job set file here? I checked. No, it wasn't here. Let me check again, just for the sanity. Wait, but where is? Oh, here. Oh! What? No, it's just recently updated. No, it has only what I have right now. It doesn't have it. But you gave me a hope. But it was in vain. Okay, let's update our changelog. What have we done? So we have our iteration 3, M1, E1, I3, and what we've done. I didn't do this. We can actually do this, sure. Shuffle pins to get calibration on one of the ends, so that the connector could be used if don't use calibration. Yes, this is done. So let's see. Edit edit TVS diodes. Protection for MOSI, MISO, STK, and power. Edit line resistors for MOSI, MISO, STK, and chip select. Edit file generation automation. Almost. Also, what we've added, pull-ups, added light, or rather strong. What did we pull up? We did pull up MISO, pull up for MISO and chip select. Did we change something else? Yes. Change the pinout of the connector. So what else did we change in this iteration of the PCB? This is actually not needed. This is a waste of energy. Is it? Mostly. I don't think it's important or that important. Or is it? Yeah, it's wasteful. Or is it? Okay, I'll keep it, but we will not do it right now. So this is done. Add a test point for calibration input. Let's do it. Let's do it quickly. So let's add test point for calibration input here. And let's see, let's set this test point footprint to one of the two we have. Test point was, but I don't want a drill, I want a dot. This, like this, yes, yes. Okay. So let's save, let's push it to the PCB. Close. Oh, this is still huge, actually. And let's just add it somewhere. Yeah. And and let's connect. Save. Oh, save. She's a 3D. Good enough. Good enough. Let's update silk screen. It seems too big. It is too big because it's not my standard. It also has this annoying ring I don't like, but whatever. This side. I did that exact thing. You did what exact thing? What should I be happy about? Your failures. What? Can you please mirror? What is going on? It's S. No, just mirror. Just mirror. Whatever. Remove this. Let's run DRC. Run. No errors. Check the PCB again. Looks acceptable. This point on calibration pin. I see. Sure. So this is a very nice idea. So, and actually let's rename this completely. This. Let's call it call. Knockout. Like that. Let's see. Yep. That's okay. That looks nice. So save, DRC again. Everything is fine. So we can save and we are done. Let's go back to the changelog. So edit a test point to the calibration input. Input, rather pin. So this and this is hello Prio. Not sure if this is a good idea. Okay, do we have anything else we would like to add? Do we? Oh, did not. Let me remember. Oh, actually, yes. Now with this remove line resistors when new version of the master PCB will be ready, and also remove CS pull up. Actually, remove all pull-ups when a new version of the master PCB is ready. This is a changelog update. Very nice. Let me push it to Git. Okay. One moment. It's E1. Updated design to I3. Pushed. Let's get back to automation. Okay, sure. That makes sense. This will stay. Okay, nice. Back to work. Lads and ladies, if there are any. We lost everything. Okay, but now it's pushed to Git, so it will not be lost anymore. Yes, it shows that it's pushed to Git. Very nice. Open job set. Let's do our copies. Copy file. And let's specify the name, which is project name, I guess. I think. .KiCAD Pro. And let's see if it works. Let's go back. Not in backup. But you don't need a backup when you push to Git, you know? It's fine. Everything is fine. We don't need this any longer. Let's run our generation script. Oh, no, don't tell me what is happening, actually. What is going on? It worked! It worked! Let's just copy it multiple times. Copy files, KiCAD Pro. To file bug report. What bug report will I even file? I had 3 crashes, but I actually have no idea how to reproduce them. So like the best I can tell them right now is, guys, your software crashes. And I have no idea why. Like if I had a reproducible way to crash it, it would be a nice bug report, but without it, I don't think it is. So let's keep going. Copy files. Copy, edit at SCH. Copy this. Rename. Nope. This. One more copy. Nope. Plus. Okay. Like this, it will be PCB. And copy that. And let's rename. Save. And let's run it again. Let's delete. Great. Noise. By the way, temperature sensor, should we put it so that to measure the and one of the MOSFET? You need to measure only one of the MOSFET. Your IC will never overheat unless you're like a dumbass, which you shouldn't be. You only need to measure MOSFETs, and you need to measure like probably low side, because low side I believe will be hotter, given that you are breaking your motor through the low side. So if you would like to limit the power stage heat dissipation, you need to measure probably low side, that one of them. So it works. Now let's do the first hard thing, which is automation. And let's execute command, rename project files. And now let's do the struggles. Let's struggle a bit. Save, open. Here. Oof, not this. This. I hope it works. If it doesn't work, then then I will suffer a lot more. So we need to run Python script that should be here. Was here. And after here it will be in automations. And after automations it will be where? Okay, it will be here, and let's rename them. They are project independent, so we don't need to do a project prefix for them. No project prefix. Last camera show. The inverse. Get hot. Does that mean something is wrong? No. Last time we checked, the driver got like to 70. No, it wasn't 70. It was 61, 62 degrees or something, and that is fine. The thing is that driver will not get hotter. Like no matter what current flows through your FETs, the driver will not get hotter itself. Because what makes driver hot is the bootstrap capacitor work and the providing of the current to feed to gates of the transistors. And this is a set value we set in parameters while programming the driver. So they up reset. And no matter how much current drivers, transistors push through the motor, like driver just does the same amount of work. So it will not get hotter. Okay, so now rename outputs.py here. And we need to provide 3 arguments. First will be it will be design iteration. Then we need our, what do we need actually? Let me open the file. It's not here. Where is it? Where is it? Project prefix, sure. It should be like that. No. And we also need to provide project name, which should be project name. Okay. Let's hope it works. Let's test it. If it works, everything else will be a ride, an easy ride. If it doesn't work, I will cry. My tears. My tears. Really, you can set current gate. Yes, you can set gate current when you set up the driver. Yes. And that's why the driver temperature will be like mostly constant. So the only way the driver temperature can change is if your ambient temperature changes, because your temperature rise is against ambient temperature rise. So what I was doing, I was planning to test it. Let's test it. Where are our outputs? Our outputs are here. So let's go back, let's delete, and let's do this. No, it doesn't work. Why? Okay, all right, sure. I need to do it like this. And that should actually fix it. No, it didn't. What? Project names, this arc-v3. What? I'm a dumbass. I'm dumbest I was dumb. I'm just stupid. Was still not. But it saved it. No, I saved it into the wrong file. I'm stupid again. Hold on a second. Arc-v here. Save. Run. Yes. Tell me it works. It works! We are the champions, my friends, but schematic doesn't work. Let's fix it. .pdf. Save. Delete. And here, remove. Save. Run. It works. Yes, it works. It actually works. Yes, sir. Let's push to Git. Immediately push to Git. No regrets and no hesitation. We also need to update our gitignore because I don't like the .history file. It seems to be something ignorable. Something more than ignorable. So I might as well just put it to gitignore. A bit later though. Let me first save the progress. Do not get lost it again. P1 updated. Add that. Copy and rename steps to the job set, job set, commit, push. So the script gets saved in the project folder, and for a new project you need to put them there as starting. No. The scripts are now with our new system are in the same location where all my libraries are, and this location is static. So all the project will, you don't need to put your script into your project. Like now we already don't have script here. Like there is no script anymore. All the scripts are in an automation folder here inside my KiCAD libraries. So all the KiCAD things I use between my projects are stored in a single repository on GitHub. And like all the scripts will be just here, and I can remove this. So now everything will be pointing to my library folder and to the automation. And that is the reason why I believe that I will be able to just copy this file between projects and it will just work. It will just work as Bethesda games 20 years ago. We can actually test it right away. Let's just test it. Let's just test it. That it will just work. I hope it will. Please work. So let's move it to, let's say, stop. Right there, criminal scum. Let's move to, let's say, E3. Move it here. And E3 is the project that, yes, I only copy job set, and I think it should work. And if it does work, like this is absolutely amazing. Like you don't need to do anything else. Like it's just amazing. So let's open here because we need to add our two variables. This was a board I used to test brake resistor behavior because I failed to design proper brake resistor circuit twice. Happens to the best of us, I know. So let's add our variables. Project prefix, and this will be M1E3. I prefer to copy nothing, but if you copy nothing, you like achieve nothing. Like how can you automate everything without copying anything? Like if you have a way to automate what I'm doing right now without copying everything, tell me. But I would love to have it. I think what I do right now is the easiest way to do it, like I see right now. I clearly, like literally don't see a way easier. Design, iteration. But what CLI? Like CLI is very abstract. Like what exactly should I do? Like what do I put into a CLI for it to work? And it's also like what do I do there? Like, can you tell me that you can do the same thing in CLI without copying anything at all? Like, show me an example, because I don't know. And I will not investigate by this word CLI alone. Let's say 3. Okay, and let's save it. First script copies PDF file into the output folder I specify. And the output folder I specify is the pass back folder level, then forward into like design project name outputs, then project name, project iteration outputs, and the PDF file should be there. And the PDF file of the schematic, like this. Like my thoughts are, if there was a way to achieve this using CLI, as you assume, why would they add job sets then? Like why would they bother adding job sets if it's possible using CLI? Like maybe it is, maybe I'm just a dumbass, but oh sure. Go. Oh. So I'm not arguing with you. I'm arguing with AI through you. Nice. No offense. Only love. So let's see if job set works. Let's see if job set works. Let's see if job set works. Ba-ba-da-ba-bam. So here I should go back here, and if I run it, it should just work. Great. It bloody works! By copying single file. If you can do it better than this, like, I will bow my head to you. Okay. Nick Warsaw, you were timed out for 15 seconds for too many symbols. I have no idea what you tried to put into chat, but you got cracked on. Can I untime out you? I have no idea if I can. I think 15 seconds just passed. So you should be all right. Can I untime out you? I don't know. I don't know. Okay, but this works and this is perfect, so let's continue working on it. I don't need this folder, and I actually don't need this file here yet. So let's not put too many things into our Git. Let's close this and get back to our actual full project we were working on. Would you have this one? Sorry, one moment. Okay, I'm back. Let's continue. We are very close to success. I don't work with KiCAD, but can I clone those jobs plus py file for later investigation for learning purpose to see? You mean my files? Sure, I can outsource them. I can outsource both them and my job set file if you want. Later, I can put it to my GitHub. Just remind me, like, tomorrow. Oh, what day is tomorrow, actually? Wednesday, yes. Just remind me tomorrow. And I will outsource something for community. For my only viewer who is active in chat. So let's continue. Let's continue. We have quite a few automation steps to go. People, if you enjoy the stream, please follow. I would appreciate it a lot. It's very important for me. So if you don't mind, please do. And let's keep going. So what is the next step? The next step is Gerbers. Oh, Gerbers will be a pain. So let's see, let's see. As a chance to switch to KiCAD is 1%. Why? I asked people to follow and everyone left the chat. Everyone left the stream. Fuck. People just don't want to follow so much. That much. It's not for me. Sure, you just don't have, like, I'd say, lots of PCB design work. And I occasionally do. Like, the last time I was designing PCB was like a year ago, but before that I was working with PCBs for like a year straight. So I have jobs on and off. Sometimes I only do embedded development, sometimes I only do electronics. Like, sometimes I do control systems, so it's just very variable. Okay, actually, like, everyone left the stream. Hello, what's happened? What did I do wrong? Do people have such reaction for asking them to follow? Uh-oh. Uh-oh. So, Gerber files. Let's not waste time. Let's screenshot this. And let's do the automation. Add Gerbers. Okay. So we need this. Too lazy to do my own sim footprint where other can do it for me. Sure. I just want to build my own like business eventually, like to design my own stuff. And that's why I try to develop at least. I'm not sure I'm doing a great job, but I try to develop my own approaches, my own rule sets, my own libraries that I control what I'm doing. And that I understand what I'm doing. So here it will be project prefix dot I project design iteration dot Gerbers. Yes, looks good to me. Export Gerbers, save, and let's test it. And let's test it out. Where the hell am I? I'm lost again. I'm actually lost. Hello? Was? Okay. And let's run our automation. Right. And let's see. Gerbers. Nice. Let's do the same for pick and place files. Okay. PCB, export position data. And for position data, what do we need? Output file, of course, it will be project prefix dot I project design iteration dot CSV. Plain text no, CSV units millimeters, of course, include only some different pins. Yes and no. Actually, when a manufacturer assembles through whole parts, do they need position data? When they do small batches, they don't, because they do it solder manually. And if they design an automated system, they design usually a custom rig, and the custom rig solves everything for you. Okay, I will actually keep it for now. I think my last way to do it was a mistake that I fully regret. My mistake from 3 hours ago. This is needed. This is needed as well. No. No. Okay. Save and let's test it. Let's test it out. I think everyone just decided to leave the stream. I think no one is interested anymore. Now I'm sad. Now I'm very sad. Let's delete it. Let's generate again. Let's see. Okay. This looks very nice, but in the wrong place. Because I need to put them. Oh, I also forgot to generate drill files. Of course I did. Of course. So here, design iteration.csv, and this will be also project prefix dot pnp slash. No, it will be twice that, like this, I believe. Let's try. Let's test. Let's delete. Let's generate. Let's open and let's see. Perfect. Why you care about viewers? I actually don't want to do it for myself only, you know. It's very awkward when you try to like stream and show stuff, you develop and like try to explain stuff and not like no one watches. It's very awkward. Like, why do I do it if no one like needs it? Is my thought. Because like I do stream a lot. I streamed every day for like 2 weeks, like absolutely every day with no skips. And like you do have expectations when you try to like do something. And the only thing that keeps me like high minded for now is that I just do the things I feel are useful and educational for me personally, so I don't waste time. But like we are on a 6.5 hours stream. Like it's not very healthy, you know, because I was streaming almost non-stop. And I worked for like 5 hours before this, so my work day is already almost 12 hours today. So it is quite a lot. What were we doing? We were doing PNP files, and I forgot to add the real files. Where are our real files? Output folder, I just copy this one. Again, real data, this. Nope. Okay. Generate map. Cerberus 2. This, millimeters. Okay. So save, and let's try it again. Did you know that I watched some part offline when I needed to remember something we talked about? No, I didn't. But I know that no one watches my YouTube VODs. No one watches them. So I would imagine that you watch Twitch VODs. But for now, my streams are mostly like I stream for you, for you alone. And for some lurkers that are here for like 10 minutes at a time. So let's delete this. And let's test it again. Generate. Gerbers, holes, perfect. Perfect. And now let's archive them. Archive everything. Oh, YouTube, okay. Okay. So one person does watch my VODs. Let's remove this and let's start using our scripts. So execute command, and this command will do what? It will archive archive Gerbers. So what will we do? I need to copy this part, but rename it slightly. It's called Python from here, automation, different script though. Let's say archive folder.py. Let me copy the name, put it here. And this one, take what? Hi YouTube viewers. You are famous on two platforms. Yes, you are famous for like 2 people who watch my stream. Such an amount of fame for you. Don't get cocky, don't get cocky. So do I need to provide anything? Now they know that I'm crazy. Sure. Okay, okay. I need to provide a arg1, which is a path to the folder. And the path to the folder is actually not like this. The path to the folder can be taken from here. And it's like that. Job settings, and we provide this here. Save. Let's test it. Let's test it. Let's see if it works. Let's see if it bloody works. So we are here. And let's run it. Hello? Brother? It failed. Oh. Oh, hold on a second. Hold on a second. What? Oh, I'm confused. But it is correct, no? Oh, no, it is not. Because I need to do this as well. Job set work path. This will work. Right? Works. Does it? It works. Does it? It works. Okay, okay. Let me push the Git again. Not lose progress to KiCAD crash. Save. And let me push you. This and this and that and this. What? Oh, I see, I see. I actually need to delete all of those. One moment, cleaning my Git. Discard all changes, discard. And where is my script? It's here. And let me push again. It's E1. Edit Gerbers, export, and archiving. Push commit. Here, here, here. Now I need to do the same for position data. So let's add custom command. And this will archive PNP. And the command will be almost identical. Almost identical, but PNP here. Save, and let's test it. And let's run it. I am running for myself, no more. PNP. Yep. It works. Very nice, very nice. Let's remove logs. We don't need them. Save. What else do we need? We are almost there. We are almost there. I think we have 2 or 3 more to add. I see industrial servo drivers of Canvas or RS in the same RG45 port. Actually, in the same port, is there like, are there some jumpers? Like, do we need to press something to switch something for them to activate? Because I believe that they need different transceivers. Oh, actually, no, it is possible, because you can just disable software-wise a transceiver. Like, if you select it in software somewhere, you can connect the same pins to the after the transceivers, so that like one transceiver is disabled and therefore doesn't care about signals, and the other one is active. So it is possible, I would assume, because the number of data lines is exactly the same, and you need a twisted pair for both of them. But we are close to success. Let's continue doing this. I don't know, may just different wires, but I would assume that wires can be the same for both. I think it's quite achievable. Do we need a servo driver? You have demand? Okay, let's see our outputs to see what else do we need to add. I know that we need to add bill of materials, but what else? I got lost again. Remove this and that and go here. So yes, bill of materials, and that's all actually. We only need bill of materials for now. Very nice, very nice. I also want to rename these files, actually. I want them to have an iteration instead of project name in the name. Right? Because everything is saved with an iteration, even here, and Gerbers are not. Another Python script incoming. No, it's provided with the motor reference you have. What do you mean with the motor reference I have? I don't think I got your point. Can you elaborate further, please? So let's add bill of materials first, and then let's work on the script to rename Gerber files. And to do that, let's actually go to schematic, just in case. Nope, nothing broken. And copy this. Copy this. And now let's go to our automation. Schematic, bill of materials. Perfect. Now I need my screenshot to see what I need to add. Boom, boom, bam, bam, bam. Boom. When you buy the server like you or they provide a driver, I just wanted to know what port they offer. Oh, I see. I actually bought my servers without drivers. I bought them from manufacturer directly. And they were actually quite cheap. It was from China directly. They were incredibly cheap, actually. I'd say that I think I bought 4 motors. And I say that this motor, which is like 200 watts, were like $50 or $60 per unit, including VAT. Or not including VAT, but they were like very cheap. Because this is like an industrial grade PMSM motor, 200 watts. And the funny thing that the 2 kilowatts motor is not much more expensive. It's like $80 per unit when you buy like single units, when you don't buy in mass. So when you buy in like thousands, they are like $30, which is incredible. Like, it's absolutely insane. It's like nuts. Quantity. DNP, DNP, DNP. Okay. DNP. sure. And here we use comma. Was? Just comma. We use this. We use comma and space. Node here, CSV. And the output file is something. Let's copy from another file. So we need project ID and project this and project that, like that. Prefix ID dot bill of materials dot CSV. Okay. Save job set and let's test it. And I'm lost again. Remove. Run. It worked. Let's see the result. Here, bill of materials. Open as a CSV. That works, and we need to add 2 more fields we're discussing, but this will be a manual task. We will add a bit later. Okay, and now we need to automate the prefix removal. So let's do that. Don't save. Let's do that. Go back, delete, and let one more execute command, which we call clean up bill of materials. And here it will be very similar to this, but we need a different script. What scripts do we need? We need strip footprint library. This one. And what do we need to strip? We need to strip here. No. Project prefix design iteration dot bill of materials dot CSV. I think it should work like that. Save and let's test it. It's deleted, right? Works, okay. Nope. Here and here, and let's see if prefixes are deleted. They are. Oh, I also need to exclude test points. Okay, this is an interesting error. Good that we added the test point to the design. So let's do it. So let's exclude our test points. Edit job settings. Can I exclude something? Can I exclude test points? What is that? Why does this work? Keep line breaks, keep tabs. Oh, I see why it doesn't work. Okay, so CSV then, sure. CSV then. Actually, it's still CSV. In schematic itself. Save job set. What do you mean schematic itself? What do you mean actually? What do you mean? What do you mean? Schematic variants, format preset, keep tabs, keep line breaks. Actually, let me Google. KiCAD exclude exclude test points from bill of materials. 1 character per second. To exclude test points from KiCAD BOM, check the exclude from bill of materials option in the symbol properties dialog for each test point. Ew. Ew, but okay. So I can go here and say exclude from bill of materials. And now it is not here. Okay, sure. Makes sense. Makes sense. Makes sense. Makes sense. That's acceptable. It is acceptable because it's part of the design anyways. Are we done? No, we're not done. We have actually 2 more tasks to go. 3 more tasks to go. 3 more tasks to go. This is done. This is saved. This needs to be on GitHub now. This needs to be on GitHub right now. Let me push it. It will be E1. Edit bill of materials generation to job set. Push. It is pushed. And now what we need to do is we need to a script to rename all the files. All the Gerber files. So let's do it. Let's call our friend Claude and wipe code them. Wipe code the script. So let's go here. Open terminal. Call for help. Dear Mr. Cloud, please write a script to rename Gerber files to the format of Gerber files. I want to remove the part like M1E1 project name and switch it with another part. I would like to provide the part I would want to remove and the part I would like to change it to as command line arguments. Let's see. Okay, sure. $100 words. What do you mean? Oh, holy cow! It's actually very long. This is the longest script, I think. Why is it so big, actually? Python rename Gerbers. Was. This doesn't sound correct to me. Oh, no, it is correct. Sure. Because we need to provide a file of what pass to what we want to rename. And my new name. Okay, this makes sense. Let's edit as a code. It should be yeah. Okay, let's read what Claude did. Rename files, not Gerber files. Name files. Let's rename this files.py. What is dry run? I don't understand yet. And this example will be different. It will be M1 E1 I4. Arc parse. Why do I need arc parse though? Because of this flag. Why do we need this flag? What does this flag do actually? Rename files. Rename files. Main. Rename Gerber's name files. Okay. Is there directory? Directory is not a valid directory. Sure. List dir directory matches if out part in F. Okay, sure. Sort everything that has this part in it. Sorry, dry run test only with no apply. I haven't read the part yet. Don't spoiler. No spoilers. So if no matches, no file containing this part found in this directory, sure, that's a good error. Print dry run if dry run else this, renaming land files in directory. A file name is in sorted matches. Okay. New file name is file name, replace old part, new part. Oh, this is so easy actually. Okay, okay. OS pass join, file name, new file name. Okay, and OS rename. Okay, I see now. Okay, this is a very good error, sure. This is a very competently written script, let's say. If dry run, no files were renamed, remove dry run to apply, sure. And done, and dry run is a bool. Okay, okay, so parser, argument parser description, rename Gerber files, no, rename files by replacing a substring in their names. Add argument directory, substrings to be replaced, M1 E1 I4. Replacing string, sure. Dry run or preview names without making any changes. Actually, very useful. Okay, this is understandable. Arcs parser, parse arcs, rename files. Okay, this looks very nice actually. This looks very, very nice. Let's save it, let's close it, and let's move it to our automation location. Automation location, which is here. So let's move it here. Rename files.py, copy. Copy, close. And let's add another script. It will be rename Gerbers. It will be before archiving. So, and let's do this here for a moment. Copy that, edit this instead of this, this, and that, and this, rename.py. Okay, I need to sneeze badly. One moment. Okay, I didn't sneeze, but I tried my best. So job set output path, project prefix, design iteration, Gerbers. Yes, and remove this, and save and generate. It didn't work. Oh yes, I'm a dumbass. I need to provide arguments. I provide no arguments. Okay, I provided a path. So what else do I need to provide? Old name and new name. Old part and new part, right? And I closed, oh my god, I closed the VS Code. So we need to provide, and actually, what order do we need to provide them? I have rename files and rename outputs. I need to rename these to rename KiCAD outputs. And let's actually do it right away. Rename KiCAD outputs. Actually, hold on a second. Can these rename files be applied here as well? It can, right? I think it can. So let's actually not rename it and let's try to use this to rename KiCAD files as well. Actually, this script will just be instead of this script. But why old part isn't known? Because we... How would you know it? Like, I would like to be able to change one part of the files to another part of the files. And if you say it should be known, then there should be a rule on how you determine this. And if there is a rule, then you limit yourself usability of the script by like having the script following this rule. And if the rule changes, then I need to change the script. And with arguments, I don't need to change the script, so it's just universal. So again, directory first, old part second, and new part third. So directory first, sure. Then old part, which is it will be project prefix. Project. It will be just project name actually. It will be project name. And let's actually not rename anything yet. Oh, actually, we can rename. Why not? And the new part will be project prefix and design iteration. Should be all right. Rename Gerbers, archive Gerbers. Okay, I have problems in styling. In names, let's do all capital. Save job. Let's remove the folder. I'm lost again. Where is my folder with outputs? It is not here. Where is it? Delete, generate. Worked. Let's see. Gerbers. They are renamed correctly and stored correctly. Perfect. This is perfect. Perfect. And now I would like to rename project files using this script. Let's save this line to some safe place, just in case we need to restore it. Yes, git push, agree. Let me push it right away. Let me push it right away. You are absolutely correct. KiCAD crashed 3 times today. And I don't want to accept that. So include KiCAD job set, and let's me edit E1, edit Gerbers, rename to the job set, push. Perfect. And now let's try to do this rename with our new function instead of a node function. So did I save the line? I did. So let's actually just let's not delete it first. Let's add new. This will be rename files for now. Edit job settings. Okay. Edit job settings. Put this, and here instead of Gerbers, it will be just this location. It will be root, and everything else can stay the same. And now we can copy the name and delete this, and pray that it works. Let's remove the folder. Remove the folder and run. It didn't work. It's not okay. Yes. Yes. Was. Oh, actually, I don't think this part is even near here. Right? It works! It works with new script. Without an old script, it just works. It just works. And I can open and I will see the latest version that I saved, that I copied. Holy cow. It's amazing. Holy cow. It's incredible. And I need to delete the log. So let's edit this job, remove this, and rename Gerbers. Should have it as well. No, it doesn't. Gerbers as well. Now save. Let's test again. Something does generate the log. You? Yes. Bloody bastard. Okay. Save. So now we can remove one of our automation scripts, which is rename outputs. Okay, let's save and let's run again to make sure we didn't break anything. PMP, archive, Gerbers, archived, renamed, perfect. KiCAD file schematic, it is correct. And now the final countdown. Let's put this to another project and see if it just works out of the box. Let's see if it just works out of the box. So copy only job set file to another project. Electronics, let's say here. Open this. Make sure that we have variables set. I remove them. Let's add them again. Project prefix is M1 E3 and design iteration is just 3. Okay. And let's save. Let's close. And let's just simply run the job set. Like we don't need to do anything else. Okay, something happened. Let's open the folder. So something definitely happened. Outputs. It is correct. The project is correct. Bill of materials is correct. Oh my god, it's so good. It's so good. It works. Everything works. I can just copy a single file and everything will work. It just works. I'm happy. Git push. Let's push it again. And what was the change? Change of script. So P1 changed script for Gerber or project files renaming. Add variables you will need to do all the time. It will be essential part of the project because it will be like the renamed variable is used in 2 places inside the project itself, so it's needed to be there. So technically it will be only a single operation, which is copy. And copy and maybe rename, because like, yes, copy and rename. But this is just amazing. That's incredible. And I also need to save it as a template to my KiCAD libraries. So let's do it as well. Remove this, go here, push, of course, to the GitHub. Exclude, and this is push. Change script for project file renaming. Commit, push immediately as up. So, and now let's copy this. We will change it, but let's save it in a separate location as well. Where this location will be? It will be here. It will be in resources. And I'd say it's template, KiCAD job set. And maybe I will need to add readme.md. Yes, and I will need to write explanation how to use this later. But I will do it off stream. And now we also have 2 other issues, and we streamed for 7 hours. Holy cow! And I also feel very tired. Should I stop for the day? Should I stop? And what other changes? We need to specify through-hole or SMT component to a bill of materials, and also a part number. Part number for the supplier to use. So we need to provide just fields for all the schematic, all the schematic symbols. Do KiCAD has new project from template? I don't know. I actually have no idea. Does it? File a new project from no. Yes, so there are templates. Can I create my own template? Can I create my own template? I think I can. So yes, there are projects from templates. And yes, if I store the template and this file as part of the template, there will be no copy movement. You are correct. You are correct. But actually this is... Okay, my camera died. My camera got 0 power. And that means I can stop the motor. Poor Spark job. Okay. Yes, I agree. I think I'm too tired. I actually am too tired at this point. I think it will be all for today. The progress was amazing. We finished the board. I will order it tomorrow probably. And it will arrive at my place probably in a week or 2. No, actually, given that I would order assembly, it will probably be more like 2-3 weeks. And tomorrow will be a stream where we will probably work on space vector modulation for our motor and or on brake resistor implementation. and maybe a bit of PCB design automation as well to finish this one, unless I finish it off stream. Thanks everyone for watching. I appreciate you being here. If you are not following and you would like to see more, please follow. I appreciate it a lot. And I'll see you in the next one. Bye bye.